So we've started the recording, and thank the Lord that you guys can't unmute yourself without me giving permission. So whoever has any question, do raise your hand and I'll let you guys unmute yourselves, right? Because last time you guys were just going here and there and here and there, right? So British Pakistanis working here and there, yeah. But that is what happened last night. So today, just raise your hand after I'm done with a particular segment, particular topic of organic chemistry. I'll give you the chance to raise your hands and ask questions. And in that particular moment, we are going to stop the recording. We just want a smoother recording, right, this time. So without further ado, let's start where we left off last night. Sir, आज कितना time लगेगा? Hopefully today it will be over by 12. Hopefully before 12, inshallah. Right? Just a little bit is left now. Okay. So we left at, if I'm not wrong, where did we leave? Oh, we left at alcohols, right? So we were talking about the chemical reactions of alcohols. What were the chemical reactions? Number one was combustion reactions, and number two was oxidation, and number three was esterification. Esterification we learned after we are done with carboxylic acids. We were doing oxidation reactions, right? We did combustion reactions. We left out carboxylic. I'm just giving you a recap. So in oxidation reactions, what was actually happening was that when you had like this beautiful alcohol, let's suppose I have ethanol, it underwent an oxidation reaction. Why? Because of this OH bond present here. The OH bond was dictating the fact that it is going to undergo the oxidation reaction. And for oxidation reaction, you needed to provide it with a catalyst that is acidified aqueous potassium manganate, right? So it's acidified aqueous potassium manganate. It's purple in color, and once it oxidizes this alcohol, it's gonna go from purple to colorless, right? So it'll become colorless. And we studied last time that in organic chemistry, when we talk about oxidation, we talk in terms of gain or loss of hydrogens and oxygen atoms, right? So we know that oxidation is the loss of hydrogen atoms, and oxidation is also the gain of oxygen atoms, right? The loss of hydrogen atoms and the gain of oxygen atoms. So what was happening was essentially that this KMnO4, we represent the oxidation with an O sign. Okay, oxidation is taking place right here. So we put two bracket parentheses and then we put an O sign to tell the examiner that this is basically oxidation which is taking place. So since KMnO4, acidified potassium manganate, aqueous potassium manganate, is an oxidizing agent, what it was doing is, firstly, this alcohol was losing the hydrogen. Why? Because oxidation is the loss of hydrogen. So this H and this H, the O bonded to H, this particular H and an adjacent H right here, these two H's were going out, right? So these two, because of oxidation, these two H's were lost. So once these two H's were going, let me take them out. Let me take these two H's out. These two H's were going away. And once they were like moving, they came in and forth said, hey, where are you going? Wait a minute, dude, here you go. Take an oxygen, because oxidation is also the gain of oxygen atoms. So the KMnO4 gives it an oxygen, and together all these three combine, two hydrogens and one oxygen combined to give you H2O. Great. So KMnO4 gives this one oxygen. Now this carbon has made 3 bonds and this oxygen has made 2 bonds. Carbon makes a total of 4 bonds and oxygen makes a total of 2 bonds. This oxygen is unhappy because it has only made 1 bond. This carbon is also unhappy because it has made 3 bonds. So carbon needs to make 1 bond, oxygen needs to make 1 more bond, and they make this bond right here, right? So they make this double bond right here. And what KMnO4 says, hey, don't worry, hold up a minute, there's oxidation is the gain of oxygen atom, so I'm going to give you an oxygen atom to bond right here with the hydrogen, right? So this hydrogen is going to move to the right a little bit, and this oxygen atom is going to come here, and that is the product that forms, right? So how do you write the oxidation equation for your alcohols? This is the product that forms. And which alcohol did we have? We had ethanol. And how do you draw the structure of ethanol? Well, obviously, it's the same as the structure of an alkane. The only thing that you do is you replace a CH bond with a COH bond, right? So how many oxygens in total did KMnO4 give it? KMnO4 in total gave 1 oxygen right here to these 2 hydrogens to give H2O, and it donated 1 oxygen right here. It gave an oxygen right here. That's why if you were to write the equation, if you were to write the oxidation equation, you're going to write 2 times O. 2 times O were actually given by KMNO4. This equation has never been tested before, but it is a part of your syllabus, so you should know this. And the product that has formed right here, this is actually the birth of carboxylic acids. This is a recap from previous class, right? So that's the birth of carboxylic acids. Carboxylic acid, this, do you know what this is in particular? This is basically your vinegar, sarka, right? So this was my ethanol, and that's a carboxylic acid that has formed, which is ethanoic acid. Sir, how do you know it's called ethanoic acid? We'll learn in a while, right? We'll learn the namings in a while. But that's one way of oxidizing alcohols, right? And I gave you the example of a cup, back then when there were no proper instruments to measure the amount of alcohol that a person has consumed. What cops used to do is they used to take a balloon and they used to fill it with aqueous acidified potassium manganate, and they used to tell the person to blow in it. So when the person would blow in it, if the aqueous potassium manganate, acidified aqueous potassium manganate would turn colorless, that would actually mean that there is alcohol present in his breath and he would get arrested for drinking and driving. Sir, तो alcohol oxidations में reactant में क्या लिखेंगे? This is the reactant, right? That's the reactant, which is ethanol, or any alcohol is the reactant, and you use a catalyst, which is acidified aqueous potassium manganate, and you also heat it. If two conditions are required, so you can also write also we heat it, right? And so once you heat it, this is the new product that forms. Let's do one more example. Let's suppose you have like an alcohol which is methethprop, that's propanol. How do I know, sir, it's called propanol? Because alcohols are exactly named the same way as alkenes, but instead of an E, you add the OL. So it's not propane, it's propanol. So what's going to happen? It's going to gain 2 O's. You need to now know how these 2 O's are gained, but we're going to make logic for ourselves. Although this is not the complete truth to it, but you have to make things easier for you guys, right? So what's going to happen? This hydrogen, the OH, the hydrogen in the OH and the adjacent hydrogen, these two are going to go, they're going to go, they're going to be, hey, we're going to be lost, because oxidation is the loss of hydrogen atoms. And once they're going, this KMNO4 gave it 1 oxygen. So they combine together, the 2 hydrogens and 1 oxygen combine together to give you H2O. And then obviously what is left behind? You have a carbon which has made 3 bonds and an oxygen which has made 2 bonds. So this will become a double bond. And this 1 O is going to be donated right here. So we are going to shift this hydrogen to the right a little bit, and we're going to add the O right here, which essentially means that the carbon is bonded to the O, which is bonded to the H. So that is our beautiful new compound that has formed. And this is my acid. That's another acid which is called your propanoic acid. Sir, how do you know the names? I'll tell you in a while. Just bear with me. Yeah. So this was our reactant, and that was the product which has formed. Yeah. I was just showing you the phenomenon right on the left hand side, the process, and then I just shifted it to the right. So that's the new product that has formed. And you would notice that every time this new product is forming, there's one thing common in it: COOH. COOH. See, and the reason why I'm teaching you this logic is just to know that there are 2 O's here. If you don't understand this logic, I will teach you an easier way, but you need to know that there must be 2 O's. So it's now your choice. You either learn the logic behind it, or you need to know, okay, whenever you have 1 OH and oxidation is taking place, 2 O's will be used. What if we had 2 OHs here? Then 4 O's would have been used. KMNO4 would have given 4 oxygen, 2 to these 2 hydrogens, 2 to those 2 hydrogens to make 2 moles of water, and also on and so forth. That has never been tested. So if that is never tested, this is never tested, most probably this will be tested maybe this time or next year, who knows, right? So that was your product. Now there was something else as well. There's also another way of making carboxylic acid. That's the first way of making carboxylic acid. The second way, which we did not discuss last night, is called the bacterial oxidation of alcohol. So this is one way of oxidizing alcohol, is by using like your catalyst, which is acidified aqueous potassium manganate, right? And in previous papers, you will know that in the marking scheme, they've also written acidified aqueous potassium dichromate, which has now been removed. For that, the color change would have been, it is orange in color, and once it oxidizes it, it becomes green. So it goes from orange to green, right? But that has now been removed. You only have one catalyst, which is acidifies, not catalyst, the oxidizing agent, which is the acidified aqueous potassium manganate, right? We should call it the oxidizing agent, not the catalyst, my bad, right? So bacterial oxidation, what is bacterial oxidation? Bacterial oxidation is also known as acid fermentation. Acid fermentation का क्या मतलब है? Making of acid, right? Fermenting acid, making acid. How does this happen? Well, you must have watched certain Bollywood movies and Hollywood movies, and in those movies, what happens is, these guys, they are late night clubbing, guys and gals, they're cool boys, cool girls, late night clubbing, party, and they come home, they open all those alcoholic drinks. The alcoholic drinks, if you notice in those movies, they are very airtight. Airtight means they have a cork in it, right? वो जो उसको shake करते हैं, they shake it and then the cork just blows up, right? So they are airtight. They use a cork to make it airtight. Airtight means that they want to prevent the contact of oxygen with alcohol. Some of you might think, why is this the case, right? Why are they making it airtight? Because what happens is, in the air there is bacteria. In the air there is bacteria, and that bacteria will use the oxygen in the air to oxidize the alcohol, the ethanol, because we know ethanol is the only drinkable alcohol. So it will use the oxygen in the air to oxidize the alcohol into the vinegar, into the acid, right? So, sir, when is the exam? Man, you are appearing for the paper, not me. You should know, right? So this is called the bacterial oxidation of alcohols. And what is that bacteria called? That's not in your course, but if you know it, that's well enough. It's called the Acetobacter bacteria. So there's this bacteria in the air called the Acetobacter bacteria. If you leave the alcoholic drink open, if you don't make it airtight, if you don't plug in the cork again, what's going to happen is over the next 2, 3, 4 days, the alcohol, the ethanol essentially, is going to start to oxidize into the acid, into the carboxylic acid, which is your vinegar. How? The bacteria in the air uses the oxygen in the air to oxidize the ethanol to ethanoic acid and form vinegar. So this can come in your paper this time around. Okay, describe the acid fermentation or describe the bacterial oxidation of alcohol. So you can write this down. Okay, the Acetobacter bacteria. You don't need to know the name of bacteria. So the Acetobacter bacteria, or the bacteria in the air, uses the oxygen in the air to oxidize ethanol, to ethanoic acid. Sir, how do you know these names? This acid name, I'll tell you in a second, yeah? And that is vinegar. Sir, if we leave it open for a short amount of time, will this take place or will it take 3 to 4 days? Usually it takes a few days. Yes, this is in the syllabus. You can open your syllabus. And this will come for 3 marks, right? So 1 mark might be for mentioning the word bacteria, 1 mark would be for oxidizing, 1 mark might be for the product, right? So this can come for 3 marks. You can open your syllabus. I am not teaching anything which is not in the syllabus. Whatever I teach that is not in your syllabus, I will tell you. Like the stories that I've told you, they are not in the syllabus. The stories that I've told you, yeah? But this is in the syllabus. Great. So that's called the bacterial oxidation or acid fermentation. If I want to write the equation for it, what will the equation be? Let's suppose you have like this beautiful alcohol, not beautiful, astaghfirullah, haram. But let's suppose you have this beautiful alcohol and you perform the oxidation. So how many O's should I add? Well, again, there should be 2 O's. For 1 OH, there should be 2 O's. And what's going to happen? The same thing is going to happen over and over again. These two hydrogens are going to be lost. These 2 hydrogens are going to be lost because oxidation is the loss of hydrogen atoms. And once they are losing, the bacteria will go like, hey, take this oxygen with you, take 1 oxygen with you, and they're going to take that 1 oxygen. They're going to be like, I'll take it. This oxygen will be like oxygen ja, they will be like oxygen ja, oxygen right? So they're going to take it and become H2O. And obviously, this carbon is unhappy, made 3 bonds. This oxygen is unhappy, made 1 bond. So they're going to satisfy each other and make a double bond. So now everybody's happy, but this 1 oxygen is going to come here. So we're going to move this hydrogen to the right a little bit and add the O here. There is a very easy way of drawing it as well. Don't worry, I'll teach you, but you need to understand this equation as well. So that's the product which has formed, which is basically your acid. And the reactant that we had was boom shakalaka. This was the reactant. Done. Sir, will we include the oxygen in the word equation? Yes, you can include it. If they say write the word equation for bacterial oxidation, you're going to say ethanol plus oxygen gives you ethanoic acid. So yes, you will. Simple. Sir, into 2 या into 1.5 अपनी speed कर लें. Chill, man. Chill. So that's how this is the birth of carboxylic acids. Now, what are carboxylic acids? What are carboxylic acids? Let's talk about this for a moment. This is the birth of a new family. So up until this point, we're done with alkanes, alkenes, alcohols, and now it's the birth of a new family, which is carboxylic acids. How are carboxylic acid formed? Two ways. Number one is either by oxidation using an oxidizing agent, which is acidified aqueous potassium manganate, and you perform this type of process usually in the industry. And the second way is the bacterial oxidation, and you end up with this product, which is the carboxylic acid. I'm telling you, this is the carboxylic acid. Sir, is this all for vinegar wala stuff? Not just vinegar. You can have any alcohol. Only ethanoic acid is your vinegar. You can have any other alcohol, and it'll still make a carboxylic acid, right? If it is oxidized. But bacterial oxidation can also happen for any other alcohol. But if you take bacterial oxidation for a drinkable alcohol, we know the only drinkable alcohol is your ethanol, right? So it's going to go into ethanoic acid. Sir, is this also an IGCSE? Please don't ask me if this is in the syllabus, because I already told you I'm teaching you whatever is in the syllabus. If you don't believe me, open your syllabus. If it's not, good for you. Okay, great. Now, let's talk about carboxylic acids. What are carboxylic acids? Carboxylic acids are weak organic acids. They're weak acids. What do we mean by weak acids? Achha, what are acids? Acids are proton donors, right? And weak acids, or so what are, first let's talk about strong acids. We know that HCl is a strong acid, H2SO4 is a strong acid, you have HNO3, which is a strong acid. These are strong acids. If you use a universal indicator, it's going to give you like a reddish color. It'll have a pH of 1 or 2. They're very strong acids. And the definition of a strong acid is acids which fully ionizes when dissolved in water, or fully ionizes in aqueous solutions, right? So they are strong acids. But weak acids are acids which partially ionizes in aqueous solutions, or when dissolved in water. What do we mean by this? Well, this is acid-base theory, so I don't feel like teaching it, but still I'll teach you a little bit of it, right? So partially ionizes means that, let's suppose you have a carboxylic acid, which is CH3COOH. Sir, how do you know CH3COOH is a carboxylic acid? I just added them. Right? So what I did was I added this carbon and its hydrogens. So that gives me CH3, and I added a carbon and COOH. Remember, we said that whenever we are writing the molecular formula, if we have an alcohol, we write the OH separately, and if we have the carboxylic acid, we write the COOH separately. So that's how I got the formula CH3COOH, right? So I got the formula CH3COOH. If I dissolve this in water, so now it's aqueous, how will this ionize? It will partially ionize. Partially ionize means that obviously when it's dissolved in water, since it's an acid, it's a proton donor. So it's going to give you this proton right here. It's going to give me the H plus ion right here. And it's also going to give me the negative ion, right? So what's the negative ion? If the H plus ion has been donated, this H plus ion has been donated, what is left behind? You're left behind with CH3COO. And remember, CH3COO, this COO always has a negative charge. This is not the charge on oxygen that you might think, oh, oxygen, sir, is 2 minus. Oxygen is 2 minus, but this is the COO minus ion. This minus is on the entire ion, right? So, sir, can we say slightly ionized? No, use the proper wordings, partially ionized. You can say whatever you want, but this is a Cambridge instructed course. Use the words that have been written by Cambridge in your syllabus, please. You can use whatever you want to explain it to a layman. Okay, so this negative ion will come as it is. Now, because we say it partially ionizes, we do not represent it with a forward arrow. A forward arrow would mean that it fully ionizes. What's the difference between fully ionizes and partially ionizes? Well, fully ionizes means that if you have 100 molecules of CH3COOH and you dissolve it in water, all 100 of them are going to convert into ions. All 100 of them are going to ionize. But if we say it's partially ionizes, that means if you have CH3COOH, which is your ethanoic acid, if you have this, partially ionized mean that if you have 100 molecules of these, only like 1 or 2% are going to ionize. All of the else would remain in the form of a molecule. They would not give you the ions. That's why we call them weak acids. Why? Because weak acids are acids which partially ionize. That's why. And the reason why they are then weak acid is because the H plus ions concentration is very low. The more the H plus ion concentration in a solution, the more acidic it is. The lower the H plus ion concentration in a solution, the less acidic it is, right? So since it partially ionizes, which means if I have 100 molecules of CH3COH, and the beauty is only 1%, fun fact, only 1% ionizes. So if you have 100 molecules, only one molecule are going to convert into ions, all the others are going to stay in the same form. That is the reason why we represent it not with a forward arrow, but with a reversible arrow. It can go, it's, you have this, but you also have more of this, right? So that is the dissociation equation of a weak acid, which you should have learned in your acid, bases and salts. So ये minus किस पे है? Just COOH or the entire thing? Now, no. This minus is over the entire thing now. This negative charge is on the CH3COO. This entire thing has a negative charge. This has the ethanoate ion that has been formed. Yeah. Now, sir, you are using ethanoic acid, ethanoate. What are you on about? Help us. How are you naming this? Let's learn how to name these carboxylic acids. Let's learn how to name the carboxylic acids. So how do we name the carboxylic acids? Basically, what you do is, remember when we talked about naming alcohols, what did we say? We said you take the naming of alkane, you cut the E and add the OL, right? So if you have like methane, you're going to cut the E and add the OL. Similarly, if you want to name a carboxylic acid, you're going to have the name of an alkane, but instead of the E, you're going to end up with an OIC. OIC, right? So it's not going to be, if I talk about a 1 carbon acid, it's not going to be methane. We're going to cut the E and replace it with an OIC and add acid to it. So it's going to be called methanoic acid. You can't get the spellings wrong, please. You can't get the spellings wrong. Okay. Then let's suppose you have, let's name some acids, right? Let's name a 1 carbon acid, 2 carbon acid, 3 carbon acid, 4 carbon acid, 5 carbon acid, 6 carbon acids. How do we name them? Let's name them, please. Okay, so a 1 carbon acid, write the name of an alkane, cut the E, add the OIC and add acid to it. Write the name of your alkane, which is ethane, cut the E, add the OIC and add acid to it. So it's going to be ethanoic acid. That's why sir knew that vinegar was ethanoic acid. How did sir know? Because it had 2 carbons in it, and 2 carbons acid is basically called ethanoic acid, right? And then let's look at the next the next acid is basically the next alkane. 3 carbon alkane is propane, but if you want to talk about the acid, you cut the E, add the OIC and add acid to it. Similarly, 4, can everybody help me with a 4 carbon acid? Butane, cut the E, add the OIC on acid. Similarly, a 5 carbon alkane, it's pentane is a 5 carbon alkane, but a 5 carbon acid is going to be pentanoic acid. Done? So I hope we now know how to name these acids, everybody. That's how we name these acids, right? Done? Hexanoic. Yes, the 6th carbon acid is going to be known as your hexanoic acid. And again, it tells us 2 things. The name will always tell us 2 things. Number 1, Pent stands for 5. So the name will tell us the number of carbons in this the number of carbons in the compound, which is 5. And the oic acid is going to tell me that it's a carboxylic acid. It's an acid, right? Now, how do you draw carboxylic acids? Let's look at how to draw them. It's very easy to draw them. Janabe wala. What we do is we draw, if you check this out, all carboxylic acid have this particular group in it, COOH. How do all carboxylic acids have COOH in it? Because of the oxidation of alcohol. When alcohols are oxidized, this is the group which will always form, right? Look at this. This is the group which is always forming. This is the group which is always forming, which is COOH, right? So it's COOH. In matriculation, I once taught a matrix student, so I used to call him Kuh. So udhar se phir maine Kuh seekha. So this is COOH, and because of this COOH, the carboxylic acids are going to undergo certain reactions, right? Because of this, is just like in alcohols, because of the OH, the alcohols underwent certain reaction, which was like the oxidation reaction. Just like in alkenes, because of the double bond, the alkenes underwent certain reactions. I'll tell you what they're called. They're called functional groups. Just wait a second. We'll do everything, right? And mein kuch bhi sawal reh gaya to bata dunga. Sir, condensation or addition while making carboxylic acid? It's neither condensation nor it's not addition. It's basically oxidation reaction. Oxidation is taking place, right? No addition, no condensation, oxidation reaction. It's a redox reaction that takes place, right? Okay, so that's the group that will be present in every single acid, right? This is the group which is present in every single acid. So what we are going to do is we're going to be very smart when we are going to be making these acids. How will we make these acids? Let's write the names first. Let's write the names again. So this one is methanoic acid. Now, hopefully we know why they are why it's called methanoic acid. 1 carbon acid, methanoic acid. 2 carbon acid, ethanoic acid. 3 carbon acid, propanoic acid. 4 carbon acid, butanoic acid. 5 carbon acid, it's oxidation, please. 5 carbon acid, it's basically like pentanoic acid. Please, you can't get the spellings wrong, right? Now, how do we draw them? It's very easy to draw them. Instead of going about it like this, oh my God, sir, if we were to draw a 2 carbon acid, now think about it. One is donkey work, one is smart work. We're going to do smart work and save a lot of time. Instead of going about it like this, sir, acids are formed when you are basically going to have an alcohol, and that alcohol is going to be oxidized. I'm going to remove these hydrogens first, and this will give it an O, and this will become H2O, and this will become a double bond, and we're going to add an O here. This is going to be such craziness. Yeah, this is going to be such a dumb work, right? Donkey work, not dumb work, donkey work. So what are we going to do about it? We're going to be very smart about it. We know that every acid has COOH in it. Every acid has. So instead of making this and making the entire structure and then ending up with an acid, like if I talk about a 3 carbon acid, instead of making a 3 carbon alcohol, then performing oxidation on it and making an acid, we're going to directly draw the structures. How do we directly draw the structures? Very easy. You will take this COOH and first of all draw this. Always. Let's talk about propanoic acid first. So I'm going to take the COO and OH. I'm going to draw this first, right? COOH, I'm going to write it first. Then what I'm going to do is, once I add COOH, then I'm going to check how many carbons are there. So prop means 3 carbons. I've already drawn 1 carbon. How many more carbons do you need? 1, 2. 3 carbons are complete, and just complete the hydrogens. 1, 2, 3, 4, 5. That's it. Let's look at another example. Let's look at butanoic acid. So how do we draw butanoic acid? First of all, always draw this group, COOH. Drew this? Sir, oxidize. Yeah, please, you guys are not, sir. Stop giving wrong information in the chat box. Oxidizing alcohol is going to take an oxidizing agent, which is acidified aqueous potassium manganate, and you're going to heat it. You don't need sulfuric acid, man. Come on, chill. That's esterification. Talal Saab, concepts weaken. Weak concepts, yeah? Sorry. Stop. जब confirm नहीं होता क्यों बोल रहे हो आप? Okay. Let's start. Where were we? Okay, so we are making butanoic acid. So we're going to write the COOH first, because this is basically the group this is the group of atoms which is responsible for the specific chemical behavior of all the carboxylic acids. Just like the OH was the group of atoms which was responsible for the specific chemical behavior of alcohols. We're going to learn what we call this later on. Just bear with me. Everybody's writing functional group. I know that you know it. Bear with me. Okay, so we're going to draw COOH, and then but means 4 carbons. So we're going to draw 4 carbons. 1, 2, 3. Why have I drawn 3? Why not 4? Because I've already drawn 1 when I wrote COOH. So 4 carbons, and then just complete the hydrogens. Boom, 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 boom. Done? Let's draw pentanoic acid. So if we want to draw pentanoic acid, we're going to draw COOH first. That's it. And pent means 5 carbons. So 1, 2, 3, 4, 5. I've drawn 5 carbons, and then just complete the hydrogens. How easy is it, man? How easy is it? So let's draw ethanoic acid. Now, ethanoic acid, first of all, draw the COOH. That's the group which is responsible for all the behavior of acids, right? So we're going to draw COOH. Eth means 2 carbons. So we just need 1 more carbon and just complete the hydrogens. Done? Then let's draw methanoic acid. First of all, draw COOH. Meth means 1 carbon. You already have 1 carbon. How many more bonds do you need? How many more bonds do you need? Carbon has already made 3 bonds. Only 1 more bond with the hydrogen, because you just need 1 carbon. So carbon is already there. What should the remainder bonds be? The remainder bonds should be with hydrogen. So that's how we're going to do smart work and not donkey work. Now look at the oxidation reaction. Instead of using all this logic, now this entire logic is useless for me. I had to teach you the concept, right? But now this entire logic is useless for me. फॉर्मेशन एसिडिफाइड एक्वस, भाई गलत लिखा है, जो किताब जिस किताब से आप बता रहे हैं ना गलत लिखा हुआ है किताब में, माफ कर दें. ओके माफ कर दें, मुझे माफ कर दें तलाल साहब. ओके जी, प्लीज लिसन, इफ यू आर टेकिंग दिस क्लास जस्ट लिसन टू व्हाट आई एम सेइंग. या बाकी जिधर सर बट माय टीचर इज सेइंग दिस, बट माय टीचर, देन टेक क्लासेस फॉर देम प्लीज. प्लीज, इट्स वेरी सब्जेक्टिव. या सो इफ योर टीचर इज सेइंग समथिंग, just then listen to the teacher, take their classes. Thank you, Ji. Thank you very much. I just get very cool. Okay, so once I got this comment on my YouTube, yeah, sir, you always bash other teachers. I don't bash them, it's the reality. Matlab, recording off recording bolunga inshallah. Okay, so that's how we do. Now instead of using all the khwari, if I were to be if they were to ask me to write the oxidation equation, for oxidation symbol equation for ethanol, am I stupid to use all my concept here? KMNO4 will give this O and this O and that O. No, 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 no. I know that if you have ethanol, you are going to have, it's going to get two O's, and what is going to form? Ethanoic acid. How do we draw ethanoic acid? Simple, simple, simple. We will first draw the COOH, and then eth means two carbons, so draw the other carbon, finish the hydrogens, and here H2 will form. So instead of using the entire logic above, we're going to save our time and draw it directly now. Done? Easy. Acha, I'm drawing these short lines. You have to complete the bonds. You have to write H, 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 right? Easy? Easy, easy. If they were to ask me to write the oxidation equation for butanol, meth, eth, proper, but, right? So that's butanol right here. OH. So what am I going to do? It takes two earths and it's going to give me butanoic acid. How do I draw? Because if you have two carbons here, obviously here you're also going to get two carbons. So if you have butanol, here you should have butanoic acid. Right? A 4-carbon acid. If you have a 4-carbon alcohol, you must have a 4-carbon acid. So do you make guest paper? It's already uploaded on the portal. Okay, so butanoic acid. How do we draw it? Meth, eth, proper, but. Okay, and then you complete the H2s. That's it. So now we have used smart work to our advantage rather than donkey work. Okay, now let's talk about, we've drawn the displayed formulas. This type of representation is called, we've learned how to name them, drawn the displayed formula. What's the next thing? The next thing is to learn how to draw the structural formula. How do you write the structural formula? Pretty easy. Let me draw the structures again. Please. Yeah. Let's draw the structures again. I'll draw the first 4 structures only. Sorry for my pathetic handwriting. Sorry. Okay, so how do we draw? These are all hydrogens. I'm not mentioning hydrogens because it's a waste of time, but these are all hydrogens, right? Now, how do we write the structural formulas? Sir, what about these students who are, okay. Okay, so how do we draw the structure formula? We are going to treat the COOH differently in the structure, separately in the structural formula, because what is the structural formula? It shows each unit in the structure. And it does not show any bonds except for the CC double bond, carbon-carbon double bond, and we are going to represent the COOH separately. Just like in alcohols, we were representing the OH separately. In carboxylic acids, we are going to represent COOH separately, right? So how do we write the structure formula? Let's start with this one right here. Let's start with ethanoic acid. So this carbon is bonded to 3 hydrogens, so I'm going to write CH3, and then it's bonded to COOH, so I'm going to write COOH. Done. Then let's look at this, the third acid, which is propanoic acid, CH3, CH2, COOH, CH3, CH2, COOH. Done. CH3, CH2, CH2, and COOH. CH3, CH2, CH2, COOH. Done, everybody? And let's write it for the first one. It's HCOOH. That's the structural formula. And now from the structural formula, we're going to derive we're going to also write the molecular formula for it. Now notice that let's write the molecular formula for CH3CH2COOH. The molecular formula is the number and type of different atoms in one molecule. You must be able to define it like this, the number and type, right? So what is the number of number and type? So what is the type of atoms that you have in this molecule? You have carbon, hydrogens, and oxygens, right? But in the molecular formula, in our course, when we are writing the molecular formula of alcohols and of carboxylic acid, for alcohols, we showed the OH separately. For carboxylic acid, we are going to show the COOH separately, right? Just like for alcohols, we showed the OH separately. For carboxylic acid, we're going to show the COOH separately. Why do we do that? I'll tell you in a while, right? So C, how many C's do you have? You have two C's and three hydrogens here and two hydrogens here. So C2H5 and the COOH is just going to drop down. The COO is just going to drop down. You have one carbon, two carbon, three carbons. You have three carbons. How many hydrogens do you have? 3, 4, 5, 6, 7. You have 7 hydrogens and COOH is just going to drop down. Similarly, here you have one carbon and three hydrogens, one carbon and three hydrogens, and the COOH is just going to drop down. Similarly, here you have one hydrogen, and the COOH is just going to drop down. Now notice a trend. This is how you write the molecular formula for it, right? Notice a trend. Sir, what if we write it simply like CHO? You can write it simply like CHO, but it is recommended. I'll tell you when to write it like CHO. The way the only place you write it as CHO is when the examiner gives you a huge ass diagram. If the examiner gives you the huge ass diagram which has the OHs in it, which has the COOHs in it, then you just sum the carbons, the hydrogens, and the oxygens, right? But when you're just writing the molecular formula of an alcohol or of an acid, it's better. Now they've changed IGCSE as well. It's better to write it as COOH, 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 right? This is the compressed formula. This structural formula is the compressed formula, the condensed version of displayed formula. And that's the molecular formula where you show the number and type of different atoms in one molecule, except we show the OH and COOH separately. Done? Now from this I can derive the general formula. Notice something. Jitne carbons hai, hydrogens are twice the number of carbon plus 1 COOH. Hydrogens are twice the number of carbon plus 1. 2 times 2, that's 4 plus 1. So hydrogens are twice the number of carbon plus 1 COOH. Hydrogens are twice the number of carbon plus 1 COOH. So the general formula for your carboxylic acid should be hydrogen, jitne carbons honge, hydrogens will be twice the number of that plus 1 COOH. But caution. If I want you guys, where n is the number of carbons, right? If I want you guys to write the today we're going to be done with organic chemistry. Today we're going to be there is no definition of general formula. The general formula is the molecular formula in terms of n, where n is the number of carbon atoms. General formula is the molecular formula in terms of n, where n is the number of carbon atoms. That's it. Okay. Caution. Very huge disclaimer that I want to give you guys here. Very, very focused. वो हमारे एक प्रोफेसर वो कहते हैं बाबू इधर ध्यान दे बाबू ओके बाबू सो वेरी sir what's the difference between the structural formula and the displayed formula? In the displayed formula I'm showing all the bonds right here. That's the displayed formula, that's the structural formula, that's the molecular formula, right? Okay, so in the general formula I am 55. So in the general formula you have to be very careful. If I tell you guys to make a one carbon give me the formula of a one carbon carboxylic acid. Give me the formula of one carbon carboxylic acid. Now students are going to be like, oh sir, just plug in 1 instead of n, right? Let's plug it in. If you plug in 1 instead of n, you're going to get CH3COOH, and you need to look at this. CH3COH is not a 1 carbon carboxylic acid, it's a 2 carbon carboxylic acid. It's ethanoic acid, not methanoic acid. What is the mistake that we did? The mistake is that if they were asking me of a 1 carbon carboxylic acid, why am I plugging 1 here? I already have 1 carbon available with me. So I'm, instead of plugging 1, I'm gonna plug 0. So anytime 0, anything times 0 is 0. H 2 times 0 is 0, 1. So H and COOH will drop down. That is the formula. If I ask you to write me the formula of 3 carbon carboxylic acid, do not plug in 3 right here because you already have 1 carbon. How many carbons should I plug in instead of N? Instead of N, I'm going to plug in 2. So C2H, 2 times 2 is 4, 4 plus 1 is 5, COOH. Done. It's a 3 carbon carboxyl. And if you notice, it's just like alcohols. Alcohols क्या थे? जितने carbons से hydrogens were twice the number of that plus 1 OH. Here, जितने carbons से hydrogens are twice the number of that plus 1 COOH. That's the only difference. Damn, that was a heavy dosage. It's okay. I can give you some free time after we are done. Yeah. Now, carboxylic acid, because it has this COOH group in it, it has this group of atoms. You guys can watch the, Tuba, you can watch the videos. What do you want me to repeat here? It's very easy, yeah? Instead of the N, you're gonna, if I ask you of a 3, or to write down the formula of a 3 carbon carboxylic acid, and you want to use the general formula, instead of plugging 3 here, Tuba, you are going to plug in 2. Why? Because you already have 1 carbon, Tuba. So how many more carbons do you need for a 3 carbon carboxylic acid? 2 more carbons. So instead of the N, I plug in 2. So C2H5COH, and already you're going to check this out, 2 and 3. This is a 3 carbon carboxylic acid. And right here, we've drawn the structure, a 3 carbon carboxylic acid, propanoic acid, right? So like for 7, we will plug in 6. Yes. If you want to rote learn it instead of understanding it, you could say whatever we are given for N. So if we are asked of like a 10 carbon carboxylic acid, we're going to plug in 9. You can rote learn it or you can understand it. So it's your choice. But this is only for the carboxylic acid. Please, if they tell you write a 4 carbon, write the formula, the molecular formula of a 4 carbon alkene, please do not plug in 3. It's only for carboxylic acid because it already has a carbon in its formula, in its general formula. Okay, so because of the COOH, carboxylic acids undergoes 2 reactions. Number 1 is acid-base reactions. Why? Because it's an acid. So acid is going to undergo all the acid-base reactions, right? And it undergoes esterification. And we know that we studied esterification in our alcohols as well. We said that alcohols also undergo esterification. Now, after we are done with carboxylic acid, we'll formally start off with the new family, which is esters, right? So let's look at the acid-base reactions. Well, you need to be very careful. It's very easy. It's going to undergo all the acid-base reactions. So when a metal reacts with an acid, what does it give me? It gives me salt and hydrogen gas. I'll just do one example for all. So metal, let's suppose I have like magnesium. I'll do the examples which are in your course. So I'll take magnesium and let's take ethanoic acid. So CH3COOH is my ethanoic acid. What's going to happen? The magnesium, since it is more reactive than this, the hydrogen ion in the acid is going to displace this hydrogen right here. It's going to displace this hydrogen right here and it's going to give you H2 gas. And what is left? You're going to have CH3COO minus. That's the negative ion which is going to be left. And you have Mg. Mg has a charge of 2 plus. So let's make the formula of salt. Cross multiply. You're going to get CH3COO whole twice Mg. Right? This is an acid-base reaction. This is not oxidation, yeah? Acid-base reactions. Acid, it's not acid-base, it's acid-metal reaction. It's a displacement reaction. It'll undergo all the reactions of acids that you've studied in acid, bases, and salts. It's just an acid, so it will undergo all the reaction of an acid. Right? Acid-base reactions and displacement reaction with metals. Sir, why do we write the anion first or the cation? You write the anion first in this case because that's the IUPAC convention. Why is magnesium? That's the IUPAC convention. You have to write it after this, right? You have to always write the metal after it. Unlike in inorganic chemistry, we write the metal first and the anion second. In organic chemistry, we write the anion first and the metal second, right? And if you want to balance this equation, it's very easy to balance it. Very easy. Instead of counting these and counting these, if your ionic bonding is strong, and you would remember this if you've studied ionic bonding from me, I taught you guys this cross multiplication is just a trick, everybody. The cross multiplication is just a trick. This is a 2 plus ion. For 2 plus ions, how many negative ions do you need? For 2 plus ions, you need to have 2 negative ions, but here you only have 1 negative ion. So obviously, you need to insert 2 right here. You need to have 2 of these ions to bond with 1 Mg2 plus. That's why we insert the 2 here, and this equation is balanced. I was talking about the part where you said alcohols go through esterification. We've not done esterification. I just said that alcohols perform esterification. they have this chemical reaction which is called esterification. After you're done with carboxylic acid, we'll learn this. Okay? So that's how you balance them up. In the end, you just check the hydrogens. The hydrogens are already balanced here. Done, peeps? Easy. Acha, what are we going to call this? This salt has a particular name. The naming is going to start from the metal, right? So it's called magnesium. Okay, let's write the word equation first. This was magnesium because nowadays they're just testing word equations. So this is magnesium plus ethanoic acid. How do you name the salt? How do you name the salt, everybody? It's going to give you magnesium. Now this ethanoic acid, the name is going to change. Now it has become an anion. Here it was in the form of an acid. Now it has become a part of a salt. So now the name changes. How does the name changes? Basically, you write ethanoic acid, but instead of the acid bit, you're going to cut the IC and replace it with an ATE. So whenever you are writing the negative ion of your carboxylic acid, you cut the IC and replace it with an ATE. So it's going to be called magnesium, not ethanoic acid, but ethanoate. And similarly, that is the reason why this negative ion, where did it go? Where did it go? Where did it go? Yeah. Right here. This negative ion is going to be called what? This is the hydrogen ion. That's the hydrogen ion. This ion is going to be called meth. Now it's a negative ion. So meth, this becomes the ethanoate. You cut the IC and add the ATE. So this becomes the ether. Just like if you have a Cl atom, you call it chlorine. When it becomes Cl1 minus, you call it chloride. Just like that, it has a particular nomenclature to it. You cut the IC and add the ATE. So that's the first reaction. It's all acid-based reaction. वैसे इधर कराना नहीं चाहिए था, but चलो करा देते हैं. Number one, right? This is the displacement reaction. Now let's look at the acid-based reaction. So this acid is going to react with like the metal hydroxide, right? Metal hydroxide. So whenever acid reacts with a metal hydroxide, what does it give you? It gives us salt and water. Yeah. Let's write it. So acid, we're going to take ethanoic acid again, or let's take like methanoic acid. Let's take methanoic acid. So HCOOH, right? Metal hydroxide. Let's take sodium hydroxide, make it simple for ourselves. So what's going to happen? The OH in the hydroxide, the OH in the hydroxide, and the H in the acid are going to combine together to give you H2O. So they're going to combine together. Why am I removing this right here? They're going to combine together to give you H2O. Now, what is the formula of the salt that's going to form? The sodium has a 1 plus charge and the HCOO will have a minus charge. Cross multiply, you get HCOONA. No need to add the brackets because it's one that is multiplying. So no need to add the brackets. So you get HCOONA plus H2O. Done? It's already balanced. Next. Okay, for 1 plus 1 minus is there. Let's look at an acid plus metal carbonate. So whenever you have an acid, it reacts with a metal carbonate, gives you salt, water, and carbon dioxide. How do we determine the charge of carboxylic acid? It's always going to be 1 minus. Just like all the group 7s are always 1 minus, just like that all the carboxylate ions, we call them carboxylate ions. Carboxylate. I did not want to use this word, but here. They're called the carboxylate as they will always have a 1 minus charge. Okay. So you don't need to know that they are called carboxylate. Okay, let's do this metal carbonate reaction. Let's do this, sir. So let's take the acid like ethanoic acid le lete hain, CH3COOH plus metal carbonate. So let's take like sodium carbonate. Make things easy for ourselves. Now, what's going to happen? The hydrogen in the acid and the oxygens in the carbonate ion are going to make H2O. They're going to form H2O. And and the CO2 that is left behind is going to give you carbon dioxide. This C's and these O's are going to combine together to give you carbon dioxide, and a salt is going to form. So what is the salt going to be? The sodium ion and the ethanoate ion are going to make the salt. So sodium has a charge of 1 plus, CH3COO has a charge of 1 minus. Cross multiply, you get CH3COO, right? And that's going to be like my Na. And then you add them together. And if you want to balance this up, why 2Na? Why 2Na? No, 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 no. They are going, it's the formula is going to be CH3COONA. The formula is going to be CH3COONA because the sodium ion has a 1 plus charge. So 1 plus and 1 minus cross multiply. But you need to understand this as well, that you have two NAs. You could use this for balancing the equation. So if you have two Na1 plus ions, how many ethanoate ions should have been required? Two ethanoate ions should have been required. So you're going to insert the 2 right here. For one sodium ion, you need one ethanoate ion. He is saying that you have two sodium ions. So for two sodium ions, how many ethanoate ions you need? Two. You insert the 2 right here. And two sodium ions and two ethanoate ions are going to give you how many sodium ethanoates? Two sodium ethanoates. Done. But the formula is going to be CH3COONA because 1 plus is enough for 1 minus. That's the formula. The formula is going to be this, but there are going to be two of these. There are going to be 2 moles of these. Why? Because you had two Na1 plus ions. So for two Na1 plus ions, you needed two CH3COO minus ions. Here, your ionic bonding is being tested. Balancing is should have been taught from ionic bonding. Sir, मैं दूसरा हाइड्रोजन कहाँ से आया? कैडी दूसरा हाइड्रोजन. दिस इज बैलेंसिंग. दिस इज द कॉन्सेप्ट ऑफ बैलेंसिंग. आई एम नॉट हियर टू टीच यू बैलेंसिंग के ये दूसरा हाइड्रोजन किधर से आया. ये यूनिवर्स का और मैन मेड की एक लिमिटेशन है. सो वी फर्स्ट राइट द इक्वेशन एंड देन बैलेंस द इक्वेशन. अल्लाह ताला ही मेक्स द बैलेंस इक्वेशन गो इनटू कंप्लीशन. So this is another concept which I will teach you guys if time kabhi bacha. ठीक है? So I'll teach you this concept later on sometime. This is a confusion that all the students have. कि सर ये एच किधर से आ जाता है. जैसे कि आप सोच सकते हैं कि यार लाइक मैग्नीशियम रिएक्ट्स विद Cl2 gives you like not magnesium reacts with Cl2. Let's take another example. Like aluminum reacts with oxygen gives you Al2O3. सर इधर तो 2 O's थे, इधर तो 3 O's हैं. ये क्या है? This is something else. This is something else. You need to know the formulas. ये formula और balancing की कहानी अलग है. Okay, it requires 30-40 minutes अच्छे खासे. तो वो किसी दिन बता दूंगा. Okay, so what is the name going to be? The name is going to be sodium. And this is no longer going to be called ethanoic acid. This is going to be ethan because now it's part of a salt. So not ethanoic, the IC is going to go away and it's going to be replaced with an ATE. So it's going to be called sodium ethanoate. If I write the word equation for it, everybody, ethanoic acid. Nowadays they are testing word equations. Ethanoic acid plus sodium carbonate gives me sodium ethanoate plus water plus carbon dioxide. So please, you need to be able to write the word equation. Be very, very careful of what the examiner is asking you. Is he asking you to write the symbol equation? This type of equation is called symbol equation. Or is he asking you to write the word equation, right? Do you want me to do one with the oxide as well? With the oxide is not going to be tested, but let's do it. Because acids also react with oxides, metal oxides, right? So let's take this as an example. CH3 COOH, that's ethanoic acid, and it will react with, let's suppose, magnesium oxide. So the H in the acid and the O in the oxide are going to give you H2O, and the H in the acid, just give me 1 second, guys. The H in the acid and the O in the oxide are going to give you H2O. And how do you write the formula? Mg will have a charge of 2 plus and CH3COO has a charge of 1 minus. You cross multiply. Just give me a second, guys. All good. Class me. I'll call you later. Okay. Allah. So CH3CO has a negative charge. So you cross multiply. What is the formula? CH3COO whole twice Mg, sir. That's going to be the formula. And how do you balance it? See, for one magnesium 2 plus ion, how many negative ions do you need? 2. It's balanced. सो आप लोग पता नहीं बच्चे इसको देख के घबरा जाते कि सर इसको बैलेंस कैसे करना है। बैलेंस करना है अगर आपको आयोनिक बॉन्डिंग सिखाई और आपको असल बैलेंसिंग का तरीका सिखाया हुआ। डन? अच्छा, हाउ डू यू मेक द स्ट्रक्चर ऑफ दिस? दिस हैज़ नेवर बीन आस्क्ड। This has never been asked. How do you make the structure? Sir, let's check this out. How do you make the structure of ethanoic acid? COOH. That's the structure. This may be tested this year. This may be tested this year. How do you make the structure? And that's the structure of ethanoic acid. What has happened is the ethanoic acid has lost this hydrogen ion. So this ethanoic acid has lost this hydrogen ion, and we know that the charge of the ethanoate is 1 minus. This minus is not on this O. This minus is on this entire molecule right here, but we show it on the O. And what has been bonded here? Magnesium has been bonded here, and magnesium has a charge of 2 plus. So when you are drawing the structure of a metal carboxylate or a salt that has been formed from a carboxylic acid, you also show the ions. Why do we show the charges on the ions? In formulas, you don't show the charges. Here you show the charge. You tell the exam. Basically, what we want to do is we want to tell the examiner or the scientist that, hey, although this is an organic molecule, this is an ionic bond which has formed. 2 plus and 1 minus. So you show this. And similarly, they might even ask you to draw the structure of ethanoate. How do you draw the structure of ethanoate? Ethanoic acid is COOH, and obviously because you just need to add one more carbon, that's the structure of ethanoic acid. And if you want to write ethanoate, ethanoate means that the hydrogen is now gone. This beauty, this baddie is now gone. Now you have a negative charge. That's how you draw the structure of an ethanoate ion. Done? So this has never been tested, although it's a part of your course. Replicate the left side and join with magnesium. What left side? Okay. Aman, chill, man. Chill, chill, chill. You are lucky that you sent this in the direct message. I would have kicked you out immediately. And I'm deleting this damn. I know you guys think I'm a very cool dude. I am a very cool dude, but please chill, okay? मतलब आप मेरे लंगोटिया यार तो नहीं है कि मैं आपके साथ ऐसी गप्पे लगाऊं, ठीक है? And there's this type of thing actually promotes sexism, misogyny, this type of things, right? तो मतलब आपने जैसे मैसेज लिखा, it is just showing me, करूंगा मैं आपसे बात इंशाल्लाह। Learn to respect women. फजूल बात की है, बेहुदा बात, घटिया बात। Okay, seriously, yeah, nowadays guys are worse than, I swear to God, worse than animals. इतनी आप थोड़ी सी शर्म हो तो क्लास छोड़ के चले जाए। सीरियसली यार, यूर राइट, नॉट ऑल गाइस, लेकिन कौन कौन से, किस किस से जान बचाए, किस किस से जान बचाए? यू लेफ्ट सच लिमिटेड ऑप्शंस। अपनी कोई इंसान, मतलब कोई बंदा, पर्सनैलिटी, हमारे एक प्रोफेसर होते थे, वो हमें यही कहते थे, नो बडी इज गोइंग टू रिमेंबर योर ए स्टार्स, नो बडी इज गोइंग टू रिमेंबर योर डिस्टिंक्शंस, एवरीबडी इज गोइंग टू रिमेंबर योर कैरेक्टर। भाई, वी हैड अ फ्रेंड, he got five he got 5 stars in his A levels. He got distinctions, multiple distinctions in his A level. Nobody even cares about him. People say, what do people say? People say, yaar bas aise banda tha, jayega. Nobody even acknowledges his accomplishments because his character was pathetic. So please develop a character that is worthy of praise. Please, seriously यार, करेंगे किसी दिन पेप टॉक करेंगे। ये डिस्कशन फोरम वाले बच्चे मेरे हाथों नहीं लगे होते ना, तो इनकी वो ग्रूमिंग नहीं होती। टीचर्स करते नहीं है ग्रूमिंग, ज्यादातर कुछ के हो जाती है ग्रूमिंग, तो सही होते हैं, कुछ की नहीं होती। इट्स ओके मैन, इट्स ओके, बट प्लीज प्लीज राइट, you have to be very careful. I am glad that you learned your lesson. Okay. Okay. Acha, moving on. Now let's talk about, this was all there was to carboxylic acids. Let's talk about esters, esterification. That's the new family. What is esterification? Basically, when a carboxylic acid reacts with an alcohol, it gives you an ester. But you need to provide certain conditions, and those conditions are, you have to provide concentrated sulfuric acid, H2SO4 aqueous, and you have to provide a temperature, or you could just say, no, you have to provide a temperature of 200 degrees Celsius. You say heat till 200 degrees Celsius. Done? So that is, thank you very much, Adyan Ahmad Saab, I love you too. If you love me, I love you too. Yeah. Okay, so these are the conditions. You need to know conditions. Now, how do we draw the structures of esters? It's very important to know how we draw structures of esters. Now, let's take an example. Acha, what are esters? Before I teach you how to draw them, what are esters? Esters basically they occur naturally in like fruits. They have these sweet smells to it. Flowers may they occur naturally, and therefore they are used in like esters. They are used in food flavorings. They're literally used in food flavor. Like वो vanilla flavorings नहीं होती, vanilla flavorings. They're used in those flavorings. They're used in perfumes because of this beautiful smell along with certain aldehyde वगैरह. So they're used in perfumes. They're also used in like solvents, organic solvents. Just like alcohol was used in organic solvents, this is also used in organic solvent. But the main use of esters are that they're used in the manufacture of perfumes and they're used in food flavoring. You need to know this. It's a part of your course. Because, and why are they used in perfumes and food flavors? Because they are very sweet smelling. Iman says, I hate this and I don't want to understand esterification. I dread this. Don't worry, it's going to be very easy for you. Olive oil is actually an ester, you know. It's not an ester, it's made from esters, right? So we use it in our beautiful salads and all of that. It has a beautiful smell to it as well. Some of you might find it good smelling, some of you might not, but it has a good smell to it. Now, okay, let's draw esters, right? How do we draw them? Well, it's very easy to draw esters. It's made from a carboxylic acid and an alcohol, right? Let's suppose you want to make an ester from carboxylic acid, which is ethanoic acid, and you want to make it from, like, let's suppose propanol. So you want to make an ester which is going to be made from the carboxylic acid and propanol. Now, what is the name of the ester going to be? We'll learn the name later on. Let's first learn how to draw it. So how do you draw it? Draw the structure of ethanoic acid. That's the COOH. How do you draw the structure of ethanoic acid? You draw the COOH, and now you check the carbons. Eth means 2 carbons. You draw the second carbon and complete the hydrogen bonds. Done? And propanol. Let's talk about propanol. So prop means what? Prop means what? 3 carbons. Meth at the prop. You draw the structure because it's an alcohol. You draw the structure the same way as if you were to draw about the for the methane for the what's it called, the alkanes. But you are going to make sure that the groups are facing each other. So here the COOH group should face the OH group. That's the only difference. So you make the entire structure the same way. Instead of placing the OH right here, I'm going to place it right on the left hand side on the leftmost carbon. Why? Because I want these two groups to face each other. Why do I want these two groups to face each other? Because once they face each other and you provide the condition, which is basically concentrated sulfuric acid H2SO4, and you heat it to 200 degrees Celsius, these are the two conditions. Once you do this, what's going to happen is the carboxylic acid is going to lose the OH and the alcohol is going to lose the H. The carboxylic acid loses the OH and the alcohol loses the H. So can we make them lose their OHs and the H? And when OH and H combine, what do they give you? They give you H2O. So one product that forms is called your water, right? That's water. And you just connect these two. Boom, 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 boom. And this is basically an ester that has formed. That's so easy, right? We'll learn the naming in a while. So that's water that we got, and we got this beautiful ester. Let's look at another one. Sir, can you please explain it once again? I'm going to give you a lot of examples. Let's do this. So let's suppose we want to make an ester out of ethanoic acid, and let's suppose you want to make it from ethanol. Ethanoic acid and ethanol. Draw ethanoic acid COOH and CH3 right here, and ethanol is CHHHHH. Draw it exactly like your alkenes. The only thing is instead of a CH bond, you're going to have an OH bond, right, with the carbon. Now, what's going to happen? You make sure that these two groups face each other, the COOH group and the OH group, right? Why do we make them face each other? Inshallah, अभी थोड़ी देर में homologous series पढ़ने वाले हैं, तो फिर समझ आ जाएगी कि मैं क्यों कह रहा हूँ. Because these two groups are responsible for the chemical behavior. The OH group is responsible for the chemical behavior of alcohols. The COOH group is responsible for the chemical behavior of carboxylic acid, right? So what's going to happen? The carboxylic acid will lose the OH and the alcohol will lose the H. The carboxylic acid loses the OH, the alcohol loses the H. You remove this, so water is formed, and you connect them. Boom. That's the ester. That's how easy it is, man. Literally, that's how easy it is. Let's make another ester. Let's make an ester of methanoic acid and ethanol. And you guys have to do this. So methanoic acid and ethanol. Let's also make an ester from like your butanoic acid and propanol. Can we do this, please? Can we make the structures? Just trying to make it structures, yeah? Trying to make those juicy structures. Okay, so methanoic acid, COOH, is meth, and we know meth means one carbon, so just complete all the other bonds with hydrogens. And ethanol, eth means two carbons, meth, ether, and you draw the structure exactly like those of alkenes. How do you draw the structure of alcohol? Make the structure of alkene, just add the OH instead of the H, one CH, right? So you make them face each other, you make the OH face the COOH, the carboxylic acid loses the OH, and the alcohol loses the H. You remove them, voila, that's the ester. नाम बता रहा हूँ, I'll tell you how to name them. Relax, wait, yeah. Let's just wait. I have to get rid of someone. Okay, this dude's gone. Hi. Seriously, yaar. O-level students think that they are so funny. They are so funny. How do we lock the meeting? Enable waiting room. Thank the Lord we kicked that student. Okay. Acha. So how do we draw the structure of butanoic acid and propanol? Butanoic acid and propanol. So but means 4. So 4 carbons acid. So how do you make it? You make the COOH, and obviously but means 4. So 1 carbon is already drawn. Draw all the other carbons, 1, 2, 3, 4, and draw, and then just complete the hydrogens. Done? Then you draw propanol. How do you draw propanol? Meth, ether, prop. Draw it the exact same way as you were to draw an as an alkene, but instead of a CH bond, you add a COH bond. Make them face each other. What's going to happen? The carboxylic acid loses the OH, the alcohol loses the H. Boom, shakalaka. You remove them, H2O forms, and you join them together. That's the ester. That's how esters are formed. Literally, quite literally. And why do we call them esters? If you look something, there's something very beautiful about all these esters. There's a connection between them. Look at this. This COO is a connection. This COO is a connection. That's the linkage. It's a link, right? Who is Zainab Zain who's joining? Okay, I'll admit Zainab Zain. Okay, so that's COO, which is a linkage forming. COO, that's a linkage forming. COO, that's a linkage forming. And we call this linkage as the ester linkage. So if the examiner says draw a circle around the ester linkage, that's the ester linkage. That's why they're called esters, because this linkage is called the ester linkage. So this linkage is called the ester linkage. This linkage is called the ester linkage. This linkage is called the ester linkage, right? Now I'm going to remove all these circles because we want to name them. How do we name esters? चलो इधर लिखा रहने दो. How do we name esters? Now, the way you name esters is that, let's start with the first ester. The way you name the ester is because the alcohol loses the hydrogen. Whenever in organic chemistry, any compound or molecule loses a hydrogen, they go from their own group to a naming group, which we call the alkyl group. So whenever because the alcohol loses the hydrogen, the propanol changes into an alkyl group. What's the alkyl group? It's just a way of naming it. So basically, instead of the alk, you write the prefix and the YL just drops down. So instead of propanol, you're going to say prop and the YL will just drop down. It becomes propyl. It becomes the alkyl in naming. Alkyl is no particular family. It's no family. It's just a way of naming it. So whenever any molecule loses a hydrogen in organic chemistry, it is going to become alkyl in its name. Its name is going to change that off to an alkyl. So the alk bit will be replaced with the prefix, which is prop, and the YL will drop down. So it's going to be called propyl. And ethanoic acid, because now it has formed an ester, the IC acid is going to change into ATE. So what is the name going to be? This basically came from the alcohol, which is propanol. So this is going to be called propyl, and this is basically your ethanoate. So the name is going to be ethanoate. The name is going to be propyl ethanoate. In the naming, we write the alcohol first. And in the structure, usually the convention is to write the acid first. Convention is to write the acid first, but it can obviously be, switch around. So you could have added the acid here and the alcohol here. No marks would have been deducted. It's just a convention to write the acid first and the alcohol second, because in the naming we write the alcohol first and the acid second. But it's the same thing, sir. For those who lose H, only for those who lose H, yes. And you will only see this in alcohols, right? In your course, it's just alcohols. I gave you a general tip. Whenever you just lose an H, your name changes. Your name changes to alkyl. Done. Similarly here, this is going to be my, it came from my alcohol bit. It's ethanol. So it's going to change into ethyl, eth, and the YL will drop down. And this is meth, eth. This will go into ethanoate. Look at this. This is meth, eth. This was ethanol. So it's going to, because it lost a hydrogen, it goes into ethyl. You can't mess up the naming. And then it's going, sir, what's the molecular formula of esters? You just sum all the hydrogens and the oxygens and the carbons. That's the molecular. There is no general formula in your course for esters. Okay, so it's going to be called ethyl methanoate. This is going to be called what? Propyl butanoate. Propyl butanoate. Done. The carboxylic acid became the ATE because now it has bonded. And here, sir, do you take classes for A levels? No, I've retired. And meth, eth, prop. This was propanol. Now it is changed into propyl. Done, everybody? So these are certain structures of esters. Now, the big thing is here. How do you write the structural formula for it? Let's write the structure. Very easy, very easy, very easy. You have to sing with me, right? You have to sing with me. How do you write the structures? Look at this. CH3, look at this. Let's start writing it. So let's start writing it. CH3, which is bonded to a C, which is bonded to an O, which is bonded to an O. What do we say? CH3, which is bonded to a C, bonded to an O, bonded to an O, bonded to a C, bonded to an O, bonded to an O. And this O is bonded to this CH2, CH2, and then this is CH3. So this O is bonded to the CH2, which is bonded to the CH2, which is bonded to a CH3. Next, let's write another one. CH3, CH3, right here. Let's write CH3 first. This C is bonded to the O, which is bonded to the O. This C is bonded to the O, which is bonded to and bonded to another O. C bonded to this O and bonded to this O. And then this O is bonded to the CH2 and CH3. This O is bonded to the CH2, which is bonded to the CH3. Next, you have H bonded to the C, which is bonded to the O and bonded to this O. Bonded H bonded to C, bonded to O, bonded to O, bonded to CH2, CH3. H bonded to C, bonded to O, which is bonded to CH2, which is bonded to CH3. You need to know how to write the structural formula. I'll tell you why in a while. Now, CH3, CH2, CH2, this CH2 is bonded to, let's admit these students again. Let's admit them. Enable waiting room, disable waiting room. Okay, so CH3, which is bonded to CH2, which is bonded to CH2, which is bonded to C, which is bonded to O, which is bonded to C, which is bonded to O. Why am I telling you all of this stuff? Because you guys, what you do is you say C bonded to O bond. No, this C is bonded to C, which is bonded to OO. This C is bonded to C, which is bonded to OO, which is then bonded to CH2, CH2, and which is bonded to CH3. So these are the structural formulas. Okay, let's suppose Sir Suleiman gave you some structural formulas. Let's suppose CH3, CH2. Before I give you the structural formulas, I want you to tell me the name of this ester, please. Ester number A, I'm not drawing the hydrogens. You can draw the hydrogens for yourself. Ester number A. Then, no, you cannot write CO2 instead of COO. No, 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 no. Okay. Then you have like, let's suppose, इन दोनों के नाम जरा बताएं. Tell me the names, please. And tell me the name of this one as well. इन दोनों की बता दें. Thank you. The first one is ethyl butanoate. Let's see. Okay, how do you know which part is from the acid and which part is from the alcohol? There's a very easy way to do it. The carbon which is double bonded to the oxygen, this carbon and all the adjacent carbons are going to come from the acid. So this carbon highlighted, this carbon and all the adjacent carbons are going to come from the acid. So this is methylpropobute. This came from the acid, so therefore the name is going to be butanoate. And the carbon which is bonded to us, which is single bonded to O, this will come from the alcohol. So this is metheth. So this is absolutely, you guys are right. This is ethyl butanoate. Done? Now, sir, what is the name of this particular compound? This is C double bonded to O, which is carbonyl. This C double bonded to O is this C double bonded to, and all the adjacent carbons are going to come from the acid. This is basically coming from the acid. So metheth prop. This is propanoate. Came from propanoic acid. Done? And this is metheth probute. So this is butyl. Okay, chill. Great. So this is butyl propanoate. Done, peeps? Now, CH3, CH2, CH2, COO, CH2, CH3. Please name this, and then CH3, CH2, 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 OCO, CH3. Please name these two. Can you please name these two? That's why I was teaching you guys the naming. The first one is ethyl butanoate. Okay. What's the second one? The second one is also ethyl butanoate. That's why I was thinking. So look at this. I've done something cheeky. This is COO, this is OCO. Let's see if you guys can get it. Those of you, somebody saying methyl butanoate. Okay, let's see. Those of you who do not get this now, make the structures. Draw it for yourself. How do you go from a structural formula to a displayed formula? Draw it from, let's start from CH3. C is bonded to 3 hydrogens, which is bonded to a C, which is bond C. C is bonded to 3 hydrogens, which is bonded to a C, which is bonded to 2 hydrogens, which is bonded to a C, which is bonded to 2 hydrogens, which is bonded to a C, which is bonded to the O, and another O, which is bonded to CH2, CH3, like this, right? So a song. C is bonded to 3 hydrogens, which is bonded to carbon, which is bonded to 2 hydrogens. This carbon is bonded to 2 hydrogens. Then it's bonded to a carbon. This fourth carbon is bonded to these 2 oxygens. So this fourth carbon is double bonded O here, single bonded O here. And then this O is bonded to the CH2. This O is bonded to the CH2, which is bonded to the CH3. Done, peeps? So this is meth. You draw it for yourself, it will make life easier for you. This is metheth. This came from the alcohol. Why? Because this is the single bonded O, right? So the carbon which is single bonded to O, all the adjacent carbons, that comes from the alcohol. And the carbon which is double bonded to O, all the adjacent carbon and that carbon comes from the acid. This is metheth. Ethyl metheth probute butanoate. Very easy, yeah? Very easy. Done, peeps? And this now, if those of you who didn't understand, just draw it for yourself. CH3, which is bonded to a C, which is bonded to 2 hydrogen, bonded to a C, with bonded to 2 hydrogen, bonded to a C, 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 bonded to 2 hydrogen. Now, this C is bonded to the O with this, and this O is bonded to the C, and this C is bonded to the O. So this C is bonded to the O, which is bonded to the C, which is double bonded to the O, which is bonded to the CH3. Done? So now you name this. So this is basically metheth. This came from the acid, ethanoic acid. So ethanoate. And this came from metheth probute. This came from butanol. So butyl. How would we know? This is such a good question, Vanya. I love this question. Vanya is saying, sir, how do you know it's a single bond? Why can it not be a double bond? Vanya, it can never be a double bond because carbon can only make 4 bonds. Therefore, this must be a single bond. Yes? This was a question which I had as well when I was studying back at your age, 5, 6 years ago. Now you get it, Vanya? because this must be a single bonded to carbon. Why? Because if it's double bond is impossible. Oxygen would have then in fact effectively made 3 bonds. It would have effectively made 5 bonds. We know carbon makes 4 bonds, oxygen makes 2 bonds. That's how we knew it. So it's a very cheeky thing that the examiner does. He gives you the structural formula. How can you make the structural formula out of the displayed formula? CH3, CH2, CH2 bonded to a C which is bonded to the O. And look at this one. How do you write the structural formula for this one? Look at this, CH3, which is bonded to CH2, which is bonded to CH2, which is bonded to CH2, and then this CH2 is bonded to the O. This CH2, oh my bad, this CH2 is bonded to the O, and this O is bonded to C double bonded O. So this O is bonded to the C, which is bonded to the O, which is bonded to the CH2, which is bonded to the CH3. So you must be able to do all of this good stuff. Done. We are done with alcohols and carboxylic acids and esters. Remember, to make an esters, you need to have certain conditions. Okay, one more thing, peeps. One more thing. We're going to learn this later on. This is basically a condensation reaction. Why is it a condensation reaction? What is a condensation reaction? You'll learn it later on when we are doing condensation polymers. But it is a condensation reaction is a reaction in which molecules, they join together to make a larger molecule with the loss of a small molecule. Molecules join together to make a large molecule with the loss of a small molecule. What is being lost? What is being eliminated? H2O is being eliminated in the process. Who asked a question? Break? Yes, we are going to take a break of 5. Said, lekin how do we know that oxygen is only bonded with carbon and not with the carbon on the acid and not the carbon on both sides? I don't know what you're saying, man. This is, I didn't get your question, right? I'll give you guys the chance to unmute yourself, and we're going to start off with, now bas ab kam reh gaya kaam. We're just left with homologous series, advanced naming. Now we're going to start off with homologous series, advanced naming, and isomers, and your entire organic chemistry will be finished. Only thing that will be left is polymerization, which is a 10-minute job. Polymerization is very easy, not 10 minutes but like 30 minutes, right? So polymerization is very, very easy. What is required is just practice. That's it. Now I'm going to pause the recording for a while and you can ask questions. If you as guys and boys, young ladke, if you guys start to work on yourself, you guys are going to thank me 3-4 years later. You're going to be like, sir, seriously, I kept my character, I kept my personality, I was not a misogynistic piece of shit. I was, sorry, misogynistic piece of crap. I'm on recording. And you guys are going to thank me in the future. Yaar, sir ki golden words say character development. So work on your character, boys. Snap out of those group chats which all the time objectify women, which all the time. Okay, this is a chemistry class, not a pep talk class. The recording has started. Okay. Okay. Chill. Let's talk about something known as the homologous series. What do we mean by homologous series? Homologous series. Homo literally means same, right? Like homophones. Have you guys studied homophones when you were in grade 6? Homophones, homo means same, phones means sounds, right? So homophones, same sounding words. So just like that, homo is a prefix which means same, and logos means features. So and series literally means family. So it's a family with the same features. That's what homologous series means, a family with same features. Now, what are those features? Well, we say that a family of compounds with certain features are called like the homologous series. So it's a family of compounds with the following features. With the following features. What are the features? Number one, the first feature is that they have a same general formula. A particular family will always have the same general formula. What do we mean by this, sir? Alkanes. Alkanes are a family, alkanes are a series, a family of compounds, and they all have the same general formula, which is CnH2n+. plus are 2, right? Similarly, alkenes have the same general formula CnH2, and this applies for every family. Similarly, alcohols have a general formula CnH2n plus 1 OH. Similarly, all carboxylic acids are going to follow the general formula of CnH2n plus 1 COOH. So a homologous, a family of compounds, a homologous series will have the same general formula. That's one feature. The second feature is that they have the same functional group. What do we mean by functional group? You need to be able to define it or describe it. What do we mean by a functional group? A functional group, let me write down the definition. It is an atom. It can be an atom or a group of atoms. It can be a group of atoms or a bond. Group of atoms or a bond responsible. Oh, you guys are unmute. Wait, let me mute you all. Sorry. Um, allow participants to not unmute themselves. Okay. So it's an atom, a group of atoms, or a bond responsible for the specific chemical properties of a family or of a homologous series. Of a family, और bracket में आप लिख सकते हैं homologous series. Done? What do we mean by this? What we mean by this is the functional group is that it can be an atom, it can be a group of atoms, or it can also be a bond which is responsible for the specific chemical behavior because of these atoms present, because of this bond present, because of the group of atoms present. The particular family undergoes certain chemical reactions, just like the alkenes. All the alkenes undergo what? All the alkenes undergo an addition reaction. Why do they undergo an addition reaction? Because of the double bond. So in this case, what is the functional group? If I were to ask what is the functional group for alkenes, it's the carbon-carbon double bond. If I were to ask you what is the functional group of alcohols, what's the functional group of alcohols? Why do alcohol? Which chemical property does alcohol? Which chemical property does alcohol show you guys? Which chemical property? It undergoes. It undergoes. It undergoes oxidation reactions. And because why does it undergo oxidation reaction? Because of this group of atoms, which is the OH atom, right? Similarly, you have like your carboxylic acids. All carboxylic acids undergo acid-base reactions, all the acid-base reactions, metal plus acid reaction, displacement reaction, they undergo esterification. Why do they do that? Why do they do that? Because of the COOH. This is called the hydroxyl group. Nobody will ask you what it's called, just for your knowledge. This is called the carboxyl group. Yeah. So carboxyl group, hydroxyl group, nobody cares. They're just called this, right? But this double bond is a functional group. This OH is a functional group. This COOH is a functional group. Why is it a function? It can also be an atom. What do we mean by an atom? Just like in haloalkenes, you're going to learn all the chemical reactions of haloalkenes, but the halogen, the X, I'm representing a halogen with the X. The halogen is responsible for the specific chemical behavior or property of this entire family. This basically determine or drives the chemical properties of that particular family. So what is a functional group? It can be an atom, a group of atoms, or a bond. It can be an atom, a group of atoms, or it can also be a bond responsible for the specific chemical properties of a homologous series or of a family, right? Now, some of you might say, sir, alkanes ka kya? Alkanes do not have any functional group. Why? Not in your course. But they do not have any functional group. I'll tell you a little simple reasoning. Alkanes do not have any distinctive reactions. What do I mean by distinctive reactions? Well, remember when alkenes were undergoing the when alkenes were undergoing the addition reaction, wherever the double bond broke, only the new atoms added there. Wherever the OH was, the oxidation took place respectively. Wherever the COOH was, the esterification or the acid-base reaction took place respectively. For alkanes, there is no such bond which will determine where in substitution reaction, there is no such bond which will determine where the chlorine is going to go. So you can substitute the chlorine can substitute this hydrogen, it can substitute this hydrogen, this hydrogen, this hydrogen. There is no particular bond which will determine which hydrogen will be substituted. You can substitute either or hydrogen, whichever you like. That is why they do not have any functional group, because they do not have an atom, a group of atom, or a bond responsible for the specific chemical properties of this. If you did not understand it, leave it. It's not in your course. You just need to know alkenes do not have any functional groups, right? Now, That's the second thing. So one feature is that they have the same general formula, they will have the same functional group. The third feature is that they have similar chemical properties or similar chemical reactions. They undergo similar chemical reactions. Undergo similar chemical reactions or have similar chemical properties. Remember, I'm not using the word same, I'm using the word similar. The reason for that is, देखिए, your ethene can also undergo an addition reaction, your butene can also undergo an addition reaction, your propene will also undergo an addition reaction, but the speed at which they might undergo an addition reaction might be different, right? The speed of the reaction might be different, something else might be different. Same means everything is ditto copy. Same means everything is ditto. Everything is not ditto. The rate of reaction is different, something else is different. So that is the reason why we say similar chemical reactions, not same chemical reactions. Although they will all undergo addition reaction, alkenes. Although every alcohol is going to undergo an oxidation reaction and esterification. Every carboxylic acid is going to undergo esterification and all that stuff. But the speed might be different, the rate of reaction might be different. That is why we say they are similar. They have similar chemical reactions. We don't use the word same for it. Sir, can't it be classified as saturated hydrocarbons? Alkenes are saturated hydrocarbons. They are, but they do not have a functional group. That's what I'm saying. Being a saturated hydrocarbon and having a functional group are two different things. The fourth property is that they all have a trend in physical properties. And we did this when we were doing alkanes, right? So as the number of carbon in every family, as the number of carbon increases, the size will increase, the mass will increase, the viscosity increases, the volatility decreases, the flammability decreases, and all of that good stuff. We've done it, right? The state changes from gas to solid, every single thing. So there is a trend in physical properties. There is a trend. You can see a beautiful increasing trend or a decreasing trend. There is no variation as such. कोई anomalies नहीं है, इतनी खास कोई variation नहीं होती. So we say that families have a trend in physical property, and in every family successive, बल्कि लिखने से पहले I'll give you the example. The fifth point is basically like, can we write the formulas? Write the formula of methane, it's CH4, ethane is C2H6, propane is C3H8, C4H10. That's alkenes with me. Can we write alkenes, please? Can we write the first few alkenes? C2H4 is ethene, propene, butene. Can we write alcohols? बस alcohols तक दिखा देता हूँ. That's CH3OH, C2H5OH, C3H7OH. Check this out. Look at the successive members or consecutive members. Check what the difference is between two consecutive members. Look at the difference. It differs by one carbon. In this particular C2H6, it has one more carbon compared to the previous molecule. It has one more carbon and has two more hydrogens. So there's a difference of CH2. Similarly, if you check these two out, there's a difference of CH2, one carbon and two hydrogen. If you check these two out, there's a difference of CH2. Similarly, in this particular family, if you check these successive members, there's going to be a difference of one carbon and two hydrogens, one carbon and two hydrogens, right? Similarly, here, there's a difference of one carbon and two hydrogens, one carbon, and every family, there's a difference of one carbon and two hydrogens. That's why we say successive members or consecutive members of a family differ by a CH2 unit. Members differ by CH2 unit. Sir, do we need to know all 5 of these properties or characteristics of a homologous series? Yes, sir, you do. Why do we need to know? Because what the examiner is doing, he says, homologous series are a family of compounds with the same general formula, same functional group, write the 2 other characteristics or 2 other properties. बस गर्क हो गए, जिन्होंने सिर्फ ये 2 याद किए, गर्क तबाह हो गए, बर्बाद हो गए, right? So don't want to put yourself as, you need to know all 5 of these characteristics of a homologous series. If the examiner does not say anything and he says write down the 2 characteristics of a homologous series, then stick to the same order. If it says 2, then write these 2. If it says 3, then write these 3. If it says 4, then write these 2 are weaker points. Like, I'm just ranking them in such a way that is preferred by the examiner. So the examiner prefers this, then this, then this, then this. Although you can write any, either or, doesn't make a difference. So this is all there was to a homologous series, everybody. Now I can safely say that how do we easily draw the carboxylic acid? So draw the functional group first and then the carbons and the hydrogens. How can we easily make an alcohol? Draw the functional group first, the OH group, and then draw all the carbons and complete all the hydrogens. See, that's how you can easily draw all these molecules. Done? This is done. Now let's look at the advanced naming. After advanced naming, we'll do isomers and then isomerism, and then we're gonna take a little break and then start polymerization. So just 20 more minutes and then we take a break. Yeah. Okay, advanced namings. Can somebody name this alkane for me? We're first looking at alkenes. Can somebody name this alkane for me? What is this alkane called? Butane. Great, great, great. Thank you, thank you, thank you. Can somebody name this for me? What is this called? Propane? This, please. Ethane. That's methane. Done? Now, if I look at butane, there are 4 carbons in a chain. These are called chains, right? 4 carbon. Here you have 3 carbons in this chain. Here you have 2 carbons in the chain. Here you have 1 carbon in the chain. IUPAC says, before I tell you what IUPAC says, a scientist, what he did was he took this CH3, he took the terminal CH3 and he placed it in the middle. He took the terminal CH3, terminal means the leftmost or the rightmost CH3. So he took the rightmost CH3 and placed it in the mid on top of this middle carbon. So what he did was he ended up with something like this. He took the 3 carbons as they were, but instead of this 1 carbon being at the right hand side, he took it and placed it on top of the 3rd carbon. So he places it on the top of the 3rd carbon. This is a CH3 unit. So he placed the CH3 unit something like this. Right? Now, IUPAC said, hey, you are calling this butane and you're also calling this butane, but this has a different structure to it. You've taken this CH3 and you placed it in the middle, in this middle carbon. So IUPAC came with a naming convention again, just like it has always done, right? So it said, how do you name, and this is called, he has branched it. The scientist, what he did was he branched it. He took this CH3 and placed it at the top. So now there's a branch created, like trees have branches, right? So this is such a beautiful branch that has been created now. Then IUPAC said, okay, the way you name branches, the way you name branched alkanes is, there are certain rules that it set out. It said, select the longest carbon chain. Select the longest carbon chain and start numbering the carbons from the side where the alkyl group is the closest. Where the alkyl group is the closest. What does he mean by this? Well, he said select the longest carbon chain, and longest के साथ लगाए unbroken. Unbroken. Select the longest unbroken carbon chain. Now, there's a very easy way to select a longest unbroken carbon chain. You're going to take your pencil, or a highlighter or whatever you have, whatever you're holding. You're going to take a highlighter, a pencil, or a pen, and you're going to start to highlight them. You're going to start to highlight them and just move about. Just move about, please. Select carbons, right? We are going to ignore hydrogens. Just move about. Here, I've selected 3 carbons. Okay, great. Here, I've selected 3 carbons again. Here, I've selected 3 carbons again. You're going to select the maximum possible chain length that you could find, right? But it should be unbroken. So how do we know it's unbroken? If you pick up your pencil from the piece of paper, it will be broken. The chain will start to break, right? So you have to use your highlighter or a pencil or a pen in such a way that you don't have to pick it up. You have to make a line, or you have to select a chain, a longest carbon chain, an unbroken carbon chain. And how do you know it's unbroken? You have to, when you start selecting, you make sure that you don't pick your pencil up. If you pick your pencil up, it will mean that the chain has been broken. What do I mean by this? What I mean by this is, look, I selected these 3 carbons and I say, oh, longest carbon chain has this carbon as well. So if I select these 3 carbons, I'm going to pick my pencil up to select this other carbon right here. So this has been broken now. This is a chain. So the longest chain is 3 carbons. Listen. Here, 1, 2, 3. So that's the longest carbon. Somebody might say, sir, 4 is the longest carbon chain. No, because I have to pick my pencil up to highlight this. I have to pick my pencil up to highlight this. And this is a very useful trick. I'll tell you why I'm telling you this trick. I'll tell you in a second. Even in A levels, this is so useful for you guys. Okay, so it says select the longest carbon chain. And now this is my longest carbon chain. Start numbering from the side where the alkyl group is the closest. Which is our alkyl group? The alkyl group is this CH3 group right here, right? It has lost a hydrogen, so now we call it alkyl group. Now, how do we start numbering? We start from the left or the right? Check this out. If we start from the left, this is 1 carbon, 2 carbon, 3 carbons. So from the left, the alkyl group is on the second carbon. If I start from the right, the alkyl group again is on the second carbon. So it does not matter in this case, either start from the left or the right. How do you name this? What is the name of the longest carbon chain? It's meth-eth-prop. So can I say the name of this longest carbon chain is propane? Absolutely, I can. And then on the second carbon, you have an alkyl group. And what is this alkyl group called? It's meth, right? It has 1 carbon. So it's methyl, because the alk bit will be replaced with the number of carbons, which is meth, and the YL will drop down. So on the second carbon, you have methyl. And IUPAC said, okay, for students, for scientists, IUPAC said, okay, for scientists, my God, sorry. IUPAC said that scientists must be able to write the name very accurately. And they said that between a digit and a word, between a digit and a letter, sorry, between a digit and a letter, you will always put a hyphen. And between 2 digits, you are going to put commas, right? But 2 digits are not in your course. Between 2 digits, we put commas, and between a digit and a letter, we're going to put a hyphen. So hyphen here, right here. So it's 2-methyl propane. That's the exact name, right? So that's how scientists said, hey, if you were to branch a 4-carbon alkane, it's going to give you 2-methyl propane. The name is going to now change. Why am I teaching you all of this? First, it's a part of your course. Second, once you learn the naming, isomers will be a piece of cake for you guys. Okay, let's check propane out. Ab dekhe. Scientists said, take these 3 carbons and take this leftmost carbon and place it at the top. Please do that. Please do that. You have C, C, and we took the leftmost carbon, which is bonded to 3 hydrogen, we placed it at the top. IUPAC says, select the longest carbon, unbroken carbon chain. Sir, take your pencil, start selecting. Boom, boom, boom. Did I have to pick my pencil up to select the top carbon? No, I did not. What is this? This is propane, this is propane. There is no branch in it. Yes, sir. Yes, sir. Let's draw this. Let me test you guys again. Let me test you guys again. Oh my God. Oh my God. Sir. Is this, what is this going to be called? This one was butane, right? Is this going to be butane or 2-methyl butane? Let's check it out. Select the longest carbon chain. Boom, 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 boom. Do I have to pick my pen up? No, I do not have to pick my pen up, which means the name is going to stay the same. It's again butane. There is no branch in it. See, that's how useful this trick is, right? Then let's look at ethane. Ethane, if I take this CH3 and I place it on top of this, let's try it out. We place this CH3 on top of this. Select the longest unbroken carbon chain. Boom, boom. I do not have to pick my pen up. So it's still going to be what? It's still going to be ethane. So the naming for alkanes changes for butane and all the other molecules after butane. Propane, ethane, methane, no branches exists in propane, methane, or ethane. That's why I made you guys draw it, right? That's all there was to alkanes. So if I were to take a long unbranched, this is called an unbranched alkane. So this is an unbranched alkane. I have not branched it. How do I branch it? I take this CH3 and place it on the middle carbon. So I take the CH3 and place it on the middle carbon. And you can also draw it like this, right? You can then show all the bonds as well. But here I'm just giving the concept. So place the CH3 on the middle carbon. Now, how do you name it? Obviously, select the longest carbon chain, methylprobute. That's butane for me right here. Select the longest carbon chain, unbroken. Remember, meth-eth-prop. This is unbroken. Achha, some of you might say, sir, why don't you select these 3? You can absolutely do that. You can absolutely do that. Now check this out. This is my alkyl group. This is my alkyl group, right? So start numbering from the side where this is the closest. It's on the first, second, third. So the alkyl group is on the second carbon. See, the name is not going to change. Look at this. If you even name it like this, the alkyl group is on the second carbon. So what is the longest carbon chain name? Meth-eth-prop. So the longest carbon chain is propane. And on the second carbon, you have the methyl group. So the name is the same, right? You can even do it like this. You can even take these 3 and make this as the branch. The name will still remain the same. What about octane? ऑक्टेन में बहुत ज्यादा बन सकते हैं, बहुत ज्यादा बन सकते हैं। आपके कोर्स में ना, आपके कोर्स में सिर्फ ब्यूटेन का है। ब्यूटेन का दूसरा स्ट्रक्चर क्या है, 2 methyl propane, so that's butane, and it has another structure which is 2 methyl propane. And let me give you guys the option to unmute because somebody is asking a question. Ji Ayan Habib sahab पूछे.
So when you put the CH3 in the middle, where
Yeah.
where does the existing hydrogen go?
Well, the existing hydrogen, basically what I'm doing is I'm taking this CH3, I'm bonding it right here, right? So if I take this CH3 and I bond it right here, this carbon essentially makes 3 bonds then, because I took this CH3 from it. So the hydrogen is basically bonded here then. Yeah? If I take this CH3, look at this. If I take this CH3 and oh my God. If I take this CH3 and I bond it right here, if I bond it right here, where does the hydrogen go? Obviously it comes here then. Done?
Okay, thank you, sir.
Welcome. In your course, you only need to know the naming of butane. And butane का name, दूसरा नाम क्या है? Butane, and the name of branched butane is 2-methyl propane. Either you rote learn it or use the concept. Sir, I did not understand से butane से पहले वालों का क्यों नहीं किया? What do you mean? पहले वालों का क्यों नहीं किया? क्योंकि नाम is the same. I did it. I tried my level best, but the name remains the same. The name is the same. The name is the same. The name is for butane. The name changed. Here the name is the same because if you select the longest carbon chain, meth prop as propane, meth ethane, meth prop, that's propane. But here you have an alkyl group. This in itself is not an alkyl group. It's a part of the longest carbon chain. सर डाई का वर्ड डाई नहीं है, डाई नहीं है आपके कोर्स में। डाई जितना था एल्कीन्स में पढ़ा दिया था। जी जी, कार्बन फ्री नहीं रहता फिर। Okay, so if you did understood this word naming convention, that good enough for you. If you did not wrote learn this for alkanes, you only have butane in your course, and butane has another structure called 2-methyl propane, and that's how you draw it. You can learn it. Pentane is not in your course. Pentane is not in your course. Pentane is not in your course. Done. But you can draw it, this is meth eth pro but pent, and if it says draw a branched alkane from this pentane, what do? You take this CH3 and you place it on top of this middle carbon, and that's how you get it branched. But it's not in your course because I'm only course focused here right now. So I'm not going to be teaching you all the names. Jo course mein wahi padha raha. Okay. Now write the structural formula, please. Write the structural formula. So the first carbon right here, the first carbon is bonded to 3 hydrogens, 2 hydrogens, 2 hydrogens, and 3 hydrogens. Carbon bonded to 3 hydrogens. We've done this before. 2 hydrogens, 2 hydrogens, and then 3 hydrogens. Look at this one. let's also draw write the structural formula for this. This carbon is bonded to 3 hydrogens. This carbon is bonded to 1 hydrogen and 1 CH3. So the first carbon is bonded to 3 hydrogen. The second carbon is bonded to a hydrogen and it is bonded to a CH3. And because this CH3 is on top of this carbon, we're going to show it with a bracket. Remember in alcohols, we studied that. We studied this in alcohols. Whenever you have the OH right here, we said, okay, this is the CH3, that's the CH. And since this this carbon has the OH on top of it, we're going to write the OH in the brackets, right? So similarly, if you have the CH3 on top of this carbon, you're going to write it in the brackets. So CH is bonded to CH3. And obviously, we'll write it in the brackets to tell the examiner that this CH3 is not a part of this chain. Rather, it's on top of this carbon right here. And then you have CH3. So आज तक स्टूडेंट्स को ये नहीं पता लगता कि ब्रैकेट कब डालते हैं कब नहीं डालते। ब्रैकेट सिर्फ ब्रांच में डाली जाती है, एंड ब्रांच में क्यों डाली जाती है? बिकॉज वी टेल द एग्जामिनर दैट दिस कार्बन एक्चुअली हैज दिस CH3 on top of it. Done. So this is all you needed to know for alkanes advanced naming. Let's look at the advanced naming for alkenes. Now again, IUPAC says my rule is the same. My rule is the same. Select the longest unbroken carbon chain. Start numbering from the side. Start numbering from the side where. Now this thing. IUPAC said, see, Alkanes, they do not have a functional group. Alkanes, they do not have a functional group. So this particular rule was enough. Select the longest unbroken carbon chain, start numbering from the side where the alkyl group is the closest. But for all the other compounds, for alkenes, alcohols, haloalkanes, IUPAC came up with one convention. He said, or IUPAC said, okay, select the longest unbroken carbon chain with the functional group. We know what the functional group is. We know what the function. So for alkenes, it should be the double bond. When we are highlighting our carbons, we should make sure that we highlight the double bond in it. When we are selecting the longest unbroken carbon chain, we will make sure that the double bond is present in it. When we are selecting the longest unbroken carbon chain for alcohols, we will make sure to select that carbon which has the OH bonded to it. When we are selecting the longest carbon chain for haloalkenes, we'll make sure that it has the carbon in it which has the halogen atom on it, right? So it says select the longest unbroken carbon chain with the functional group, start numbering from the side where the functional group is the closest. This rule applies closest. This rule applies to alkenes, alcohols, carboxylic acids, not carboxylic acids, they're not in your course. Alkenes, alcohols, and haloalkenes. Let's look at the examples now. And that's it. Finished. So let's look at the examples. Let's draw butene. Sorry, let me draw some structures, right? Let's draw this structure like so. Now, scientists, once they drew this structure, what was this structure called? What was this structure called? This structure was called meta-ether-proper-bute. We said that this structure is called butene, but now scientists said, hold up a minute. Hold up. Hold your horses. I am never going to call this butene. What? Scientists said, why? He said, we are going to use the proper naming of IUPAC. What does IUPAC say? IUPAC says select the longest carbon chain with the functional group. Start numbering from the side where the functional group is the closest. Functional group is closest on the left-hand side. So we'll start numbering our carbon chain from the left. 1, 2, 3. We start numbering the longest carbon chain, right? The unbroken. Now, you're going to say, okay, it's butene. But scientists said, hold up a minute. Between the but and the ene, there's going to come a digit. Sir, what digit is going to come in between but and ene? Scientists said that the digit is going to be where the double bond is. So the double bond is between carbon 1 and carbon 2. You're going to select the smaller digit out of this. So between carbon 1 and carbon 2, if the double bond is between carbon 1 and carbon 2, you're going to select number 1. So 1 is going to come here. And between a digit and an alphabet, or a digit and a letter, you are going to have hyphens. So this is but1ene. So now this is no longer going to be called butene. This is going to be called but1ene. Yeah, scientists be like, hold on, my beer. Okay. Similarly, can we name it as but3,1ene? Why 3? Why 3? No. Where is 3 coming from? The double bond is between 1 and 2. So you're going to select the smaller number after 1. Butene के बीच में एक number आना चाहिए. The position of the functional group. Counting from the other side. No, you cannot count from the other side. That's what IUPAC is telling you. Start counting from the side where the double bond is the closest. If you count from the right hand side, the double bond is in between 3 or 4. 3 and 4. Is 3 or 4 closer, or 1 or 2 closer? 1 or 2 is closer. What if the double bond is in the mid? Let's start. Let's look at this. So scientists said, just like you guys raised this question, the other scientists say, hey, I'm going to draw the same structure, but I'll draw the double bond in the mid. I'll draw the double bond in the mid. I'll take this double bond and I'll place this right here. They said, okay, do it. Once they did it, complete the hydrogens. We don't care about the hydrogen, right? We just focus on the carbons. When we are naming it, we ignore all the hydrogens. Now, sir, if it's between 3 and 4, we should still name it but1ene. It's not between 3 and 4. This is the incorrect naming. 1, 2, 3, 4. There is no such thing as 3 and 4 ke beech mein exist kare. No. IUPAC says start naming from this side. This is wrong. IUPAC says this is wrong. Start naming from the side where the alkyl, where the double bond is the closest. Now look at this. If we start from the left side, 1, 2, 3, 4. The double bond is between carbon 2 and carbon 3. And if you start from the right, the double bond is between carbon 2 and carbon 3. So does it make a difference? No, it does not. You can start from the left or from the right. So it's going to be called butene. Scientists said, hold up, it is butene, but you have to write the position of the functional group. The functional group is between which and which carbons? It's between the carbon 2 and carbon 3. So I'm going to select 2 or 3. I'm going to select the smaller out of these. So I'm going to select 2. So it's called but2ene. So if it's between 3 and 4, the starting will be from 4, right? And we will say, since it's 1, we are starting from the closest. Yes, you'll always start from the closest, right? From the side where the functional group is the closest. So this is the functional group from alkenes. So this is closest on the left. So you start from the left. This is in the mid. You can start from left and right, both. There is no 2,3-methyl octane in your course, and what's wrong with you? Okay. Then scientists also wondered, okay, what if I take these 3 carbons, I take this CH3 and place it on this middle carbon. I take this CH3 and place it on the middle carbon. You could do this. You could do this as well. So scientists, they took this CH3, and instead of it being the terminal carbon, you take the terminal carbon, place it in the middle. You took the terminal carbon and he placed it in the middle. Now, how do you select your longest carbon chain? Remember, the longest carbon chain should include the functional group. This can never be the longest carbon chain, never, because you have excluded the functional group. So you always start highlighting from where the double bond is. So select the longest carbon chain. These 3 are my longest carbon chain. You could have also gone like this, 1, 2, 3. The name would be same. So select the longest carbon chain, 1, 2, 3. Start numbering from the side where the alkyl group is the closest. It's 1. We start, sorry, not the alkyl, sorry, the double bond, the functional group. 1, 2, 3, right? So what is the name going to be? It's methyl. The second carbon has the alkyl group. The second carbon has methyl. So you have 2-methyl. And what is the name of the longest carbon chain? Meth-eth-prop. It's propene. But remember, we will not call it propene. We are going to insert the position of the functional group between prop and ene. So what's the position of the functional group 1 and 2 के बीच में? To insert the smaller number, it is 2-methyl propene. Prop 1 ene. What happens in hept? Hept is not in your course. जो आपके कोर्स में मैं वही करा रहा हूँ. जिनको ये शौक है हेप्ट का क्या है, ऑक्ट का क्या है, बता दूंगा एंड में. If you guys want to know hept ka kya hai, oct ka kya hai, I'll tell you at the end. Yeah, but these are the only namings in your course. Sir, I don't understand the 2-methyl part. This is the alkyl group on the second carbon, just like in alkane. On the second carbon, you add the methyl group on this because it is 1 carbon, right? So on the second carbon, it is methyl because it has lost a hydrogen. Second carbon pe methyl has a 2-methyl, meth-eth-prop, it is propane. Here on the second carbon, you have methyl, so 2-methyl, meth-eth-prop, it's propene, but you have to insert the position of the functional group. Hopefully it makes sense. So that's it, yeah? That's it. अच्छा वैसे मेरा एक सवाल है. Can you guys name this for me? And can you guys name this for me? Will they have the same name or is the name different? सर टू alkyl group में ethyl आता है, बिल्कुल टूबा आता है, लेकिन आपके कोर्स में नहीं आता. बिल्कुल आता है, आपके कोर्स में नहीं आता. सेम नेम. ग्रेट. इट्स वेरी इंपॉर्टेंट टू नो दी सेम नेम्स. आप अभी आपको पता लगेगा, आपको सब कुछ हलवा लगेगा. आइसोमेरिज्म 2 मिनट का काम है, नाम है तो सीख ले. It's meth-eth-prop. Start numbering from the side where the double bond is the closest. 1, 2, 3. So it's gonna be propene. But between prop and ene, we're gonna insert the position of the functional group, which is at 1. So prop 1 ene. Let's start. Let's highlight the longest carbon chain, which is meth-eth-prop. Start numbering from the side where the alkene double bond is the closest. So the double bond is closest to from the right side. So I'm gonna start numbering from the right side. So it's going to be called propene, but there's going to be a digit, the position of the functional group between propane, which is 1. So they are both propene. It's very important that you know these things. मैं बता रहा हूँ, इसका वजह है, बताता हूँ. अब आपको पता लगे मैं सारा क्यों बता रहा हूँ. Okay, let's look at alcohols, but that's it. So you realize that your isomerism in alkanes, they also start from butane, and in alkenes they also start from butene from the 4th carbon. Sir, why not 2 though? Because I've told you this is the IUPAC convention. IUPAC says start numbering from the side where the functional group is the closest. This is the double bond. The double bond is the functional group. So you start numbering from the right side. You cannot start numbering from the left, because if you start from the left, the functional group is further apart. Thank you. This is the same thing over and over again. See, just like in this case, you can't start from the right, you are restricted, you have to start from the left. And between 1 and 2, you have to select the lower number. Okay, let's look at alcohols. Let's draw like a 3-carbon alcohol. So the naming is the same. Select the longest carbon chain with unbroken carbon chain with the functional group starts numbering from the side where the functional group is the closest. This is the OH. The OH functional group, right? मैं इसको ऐसे लिख देता हूँ. I can make it easy for you guys, right? Select the longest carbon chain, meth, eth, prop. This is propanol, but hold your horses. Propan and ol. Between them, there is going to be a digit. What is the digit going to be? The digit is going to be the position of the functional group. What is the functional group? It is right here. How do we start the numbering? We start numbering from the side where the functional group is the closest. So 1, 2, 3 from the left. 1, 2, 3. The functional group is on the first carbon, so it's not propanol, it's propane 1-ol. Madrase mein chemistry pad rahe. Yes. I'm just, just chilling with you guys. So it's on the first carbon, so it's propan 1-ol, right? Please do not make videos out of, do not make snaps out of this. How are your pitch so far? Because I have studied in a madrasa, so I know how it goes. Yeah. Sir, I have a question. Please hold your questions for a moment. Let me just finish the namings. Okay, this is propan 1. What the scientist said, what if I put the OH right here? See, I am changing the position of the functional group. Here in alkenes, I was changing the position of the double bond. And I also took the CH3 and placed it on top right here. In alkanes, there was no functional group, so I was just taking the CH3 and placing it on top. In alcohols, you have the functional group right here. So they said, what if I put this on the second carbon? Scientist said, put it on the second carbon. So put it on the second carbon. When you put it on the second carbon, now you have the OH. So select the longest carbon chain, boom shakalaka, start numbering from the side where the OH is the closest. So where the functional group is the closest, which is the OH in this case. So if you start from the left or if you start from the right, both are the same thing. In both cases, you get 2. So you can start from left, right, either or. So here, this is propanol. But you are no longer going to call it propanol. You're going to put the position of the functional group, which is propan, and the functional group is on the second carbon. So propan 2-ol. Remember, जो इससे पहले हमने naming सीखी थी, वो सारी अब cross हो जाएगी. Now you are going to name it as not butene, but but1ene if the double bond is in the. हाँ, अगर structure आपके पास नहीं है, फिर butene लिख लें. अगर structure नहीं है, butene लिख लें. फिर तो मजबूरी है. We don't know where the double bond is placed. We don't know. If they say, what is a 3-carbon alcohol? Why do we say propanol? Because we do not know the position of the functional group. If you tell me it's a 3-carbon alcohol with the OH on the first carbon, then it'll be propan 1-ol. If the position is on the second carbon, it'll be propan 2-ol. Lakadamar. Yeah. Done, peeps? Easy. Similarly, what if I say, hold on. See, this is going to be called what? Butan 2-ol. This is going to be called what? Butan 1-ol. Now I expect you guys to know this. This is butan 2-ol. That's butan 1-ol. Done, peeps? Acha, what if just like Tuba was saying, what if I place this on the third carbon? What if I place this on the third carbon? Sir, place it on the third carbon. Place it. Will it be butan 3-ol then? If I place it on the third carbon, will it be butan 3-ol? That's my question. No. Thank you very much, everybody. Why will it not be butan 3-ol? Because when you select the longest carbon chain, you will start numbering from the side where the OH is the closest, which is the right-hand side. So this and this are the exact same structures. They have the exact same names, everybody. Achha, one more thing that you need to know, that branched structures, these branched structures, like if you look at this branched alkane right here, I forgot to tell you this, it's very important. Branch structures, you just need to know this, branch structures have a lower boiling point. Why do they have a lower boiling point? Not in your course, but they have a lower boiling. I'll tell you a little bit. Because the branch chains, they cannot get so close together with each other. So less energy is required to separate them to form a gas, right? That's why they have a lower boiling point compared to the unbranched structure. You just need to know, okay, the unbranched structure has a higher boiling point compared to a branch structure which has a lower boiling point, right? In every particular compound, a branch structure has a lower boiling point compared to an unbranched structure. It's because the branch structure has less intermolecular force of attraction. Who cares, right? But the reason why you need to know is sometimes they say branched alkane has a lower boiling point or unbranched, the branched alkane. That's all there is to it. And a fun fact, guys, that's why when you use these cars for racing, what do we mean that they cannot come close? You learn this in A levels. Okay? For now, just mean that they have weaker intermolecular force of attraction. इसको ऐसे समझे. अगर ये, if this is 4 carbons, and these are 4 carbons. Look at them. They're coming so close into contact with each other, right? So they have stronger intermolecular force of attraction compared to these two, because this CH3, because this CH3 is going to push away this structure. So they're going to be a little farther from each other, right? They're going to be like this. So there's a greater distance between them. But who cares? You don't need to know the reasoning for it. Just know they have a lower boiling point. Great. Okay, so where was I? And that is, I'm giving you a fun fact. That is the reason when you have racing cars like these, all these Formula One, those of you who watch Formula One, yeah. So in Formula One, you have unbranched alkenes, but you also add unbranched alkenes, unbranched fuels, but you also add, you have branched fuels, but you also add unbranched fuels to it. Why do we add unbranched fuel to it? To control the petrol combustion. We want to control its combustion. क्यों हम combustion control करना चाहते हैं? क्योंकि इतनी तेजी से होगी तो वो तो सब कुछ जल जुला देगा. So much thermal energy is going to be released, right? So we usually used our unbranched structures when we are using them as a our branch structures when we are using them as a fuel. Why do we use branched structures? Because they have a lower boiling point, less energy. वो सल्फ नहीं दे रहे होते गाड़ी में, जब सल्फ दे रहे होते, you can remember it from a practical example. गाड़ी में when you are turning the key, that is basically the sulf that you are giving it. So the branched structure, if you have a branch structure as a fuel, it will have a lower boiling point. Therefore, even if you move the key a little bit, it will start to undergo combustion. But you need to add certain unbranched structures as well to control the combustion. That is why you need Formula One. When you're putting the fuels inside those beautiful cars, you also have to add branched alkanes and branched hydrocarbons and branched fuels, because that branched fuel is going to control its combustion, because it's going to have a higher boiling point, right? So it's going to take time. So this is the practical example from which you could. Now, these were all the names in your course. These were all. Acha, how do I write the structural formula? Did we write the structural formula right here? So the structural formula is pretty simple, right? Here you have CH3, which is bonded to a CH, which is double bonded to a C, which is bonded to a H, which is bonded to CH3, and butene, right? If you check this out, butene, it is a CH2. This does not, this is 1. अच्छा ये मैंने 1 लिखा हुआ था. This is CH2 double bonded to CH, which is bonded to CH2, which is bonded to CH3. Done. If you want to write the formula for these alcohols, how do we write the formula for all the alcohols? इसको मैं इधर लगा लेता हूँ, right? So how do we write the formula? Let's write it for this butane 1-ol. Butane 2-ol. So first one is CH3 bonded to a CH, which is bonded to an OH, and I'm putting them in the bracket to show the examiner that the OH is on top right here, which is bonded to CH2, which is bonded to CH3. Beautiful. Here, check this out. CH3 bonded to CH2, bonded to CH2, bonded to CH2, which is bonded to the OH. Here, I don't need to add any brackets because it's the last carbon here. So automatically, we know that it's bonded right here. Done. Now let's look at isomerism. 2 minutes. Isomerism will only take 2 minutes, and then we'll take a 5-minute break. What is isomerism? In our course, we only have structural isomers. What are structural isomers? Structural isomers are compounds with the same molecular formula but different structural formula. Right? Oh, I forgot to teach you guys for haloalkenes. Look at this. For haloalkenes, quickly look here. This is going to be called what? This is going to be meth eth prop. Prop 1. अब इसमें जो है पहले number आएगा number. Here it's going to be called 1 chloro meth eth propane. This is 1 chloropropane, and between 1 and C you are going to put a hyphen. And if God forbid I put the Cl right here, that is going to be called metheth prop. So it's going to be called chloropropane. It's still chloropropane, but now it's not 1 chloropropane. It's going to be called 2 chloropropane. Done, dusted. Okay. So structural isomers. What are structural isomers? Compounds with the same molecular formula but different structural formula, right? Same molecular formula but different structural formula. What do we mean by this? Well, you need to understand this. How do we know? How do we know? They're going to have the same molecular formula. For example, C4H8. That's butene. So they're going to both have the same molecular formula, but they're going to have different structural formulas. What do we mean by different structural formula? Different structural formula literally means that they are going to have different names, my G's. If they have different names, everybody, that means that their structures are also different. That's why I took so long on naming. Khatam isomers, khatam, khatam. Bataएं जी, are these two isomers? Yes, no. Are these two isomers? Are these two isomers? Yes, no. How do we know these are isomers? How do we know these are isomers? Sir, yes, they are isomers. Yes, they are. You don't even have to name them. You just know that their names are different because they have the same molecular formula, which is C4H8, C4H8, but different structural formula. Different structural formula. How do we know? This is but1ene. That's but2ene. So if the name is different, the structural formula is different. That's it. That's it. That's it. That's it. Acha, are these two isomers? अब बस practice रह गई है. Are these two isomers? Yes, sir. Yes, sir. No, sir. Yes, sir. No, sir. Yes, sir. No, sir. Are these two isomers? Are these two isomers? Yes, no. Yes, no. Yes, no. Yes, no. Yes, no. No, 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 no. Why? Because they do not complete. No, no, Maheshba, they are not isomers. Why? Because they do not complete the basic requirement for it to be isomers. Because they should be compounded with the same molecular formula. Check out the molecular formula. Here you have 4 carbons. Here you have 5 carbons. They do not have the same molecular formula. This is an alkene, C4H8. This is C5H10. How? Yeah. Polymers break के बाद, yeah. So these are not अच्छा 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 are these two isomers? अब आज के बाद आपकी isomerism में गलती नहीं होगी. जी बताएं 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 बताएं. Are these two isomers? Yes, no, yes, no. Hadi saying yes. Hadi saying yes. Everybody saying no, no, no. Yes, they're not isomers. Why? Because select the longest carbon chain. Meth, eth, pro, but. It's but1ene, and this is what? This is what? Meth, eth, proper, but. This is but1ene because we start numbering from the side where the double bond is the closest. Done? Easy. So these are structural isomers. Now, there are types of structural isomers. What are the 3 types of structural isomers? Structural isomers have 3 types. अच्छा, आप मुझे जरा एक बात बताएं. Structural isomers have 3 types. One is called chain isomerism. This one is called position isomerism. And the other one is called functional group isomerism. Functional group isomerism will not be tested, functional group isomerism is not that tested, but position and chain isomers are tested. What is position isomer and chain isomer? You don't need to know the differences between the three. It's just to make things easy and to make your concepts clearer, right? So chain isomers are only possible in alkanes. What are chain isomers? In chain isomers, you vary the length of the carbon chain. We vary the length of carbon chain. It'll make making isomers easy for you. So you vary the length of carbon chain because if like you have butane, so in alkanes only chain isomerism is possible. So I'm going to vary the length of the unbroken carbon chain. So here you had C, here I varied its length. First it was 4 in length, now it's going to be 3 in length. Great. So that's that. Position isomers. In position isomers, you change the position of the functional group. So change the position of the functional group. What does this mean? It basically means if this is but1ene, to be more specific, I've changed the position of the functional group. First, the double bond was right here. Now the double bond is between the second and the third carbon. It was between the first and second. Now it's between the second and third. So this is called position isomers. And alkenes can also have chain isomers as well as position isomers. Why? Because the CH3, you could take this and place it on top. So it's going to have another isomer as well. So butene ki isomers are essentially in your course. You have but1ene, but2ene, and 2-methyl propene. They are all isomers. So C4H8 has these 3 isomers. Only these 3 isomers. Why? You used to be scared of isomers. Now it's so easy. So easy, yeah? Why these 3? Because they all have the formula, molecular formula C, C4H8, and they all have different structures. So butene is like this, and methyl 2-methyl propene. So meth eth prop, that's propene, and it's on the second carbon you have the methyl. Prop 1-ene, yeah. Prop 1-ene. 2-methyl propene, prop 1-ene. You can write propene or prop 1, it's the same thing in this particular case. Because डबल बॉन्ड और किधर जाएगा, इधर ही आएगा. अगर हाँ इधर लगा दिया खुदा ना खास्ता डबल बॉन्ड, तो फिर भी नंबरिंग इधर से शुरू होगी. So it's always going to be this. Sir, what is the difference between functional group isomers and position isomers? Let me give you an example. Give me a second, यार. ये इधर जरा मैं करूँ काम. What's the difference? अच्छा हाँ, the difference between the functional group isomers and functional group isomers में क्या है? Functional group isomer is कि the entire group changes. For example, आपने बस मुझे बताना है ये isomers हैं कि नहीं. आपने मुझे बस सिर्फ ये बताना है, ठीक है? C, like double bonded to O, bonded to H, and C double bonded to O, bonded to CH3, bonded to H. देखिए जनाबे वाला, देख मगर प्यार से. This is COOH. This is something called aldehyde. Nobody cares what it is. This is C double bonded to O. मुझे जरा आप एक बात बताएं, इसकी molecular formula please बताएं जरा. Molecular formula is C3H H6O, C3H6O, and here the molecular formula is C3H6O. But the functional group has changed now. Here you are changing the position of the functional group, the already present. Here you've literally changed the functional group. This is COOH. This is an aldehyde functional group. This is a ketone functional group, not in your course. Literally, not in your course. Could you show the haloalkanes again, जो आपने Cl बनाया था? देख लें. अच्छा, जिनको ये नेमिंग समझ नहीं है ना, अब those of you who don't understand the naming, what can I say? जो ब्यूटेन मैंने समझाया था, 2-methyl प्रोपेन याद रख लें, ब्यूटेन याद रख लें कि ये 2 आइसोमर्स है, और एल्कीन के ये 3 आइसोमर्स हैं, और अल्कोहल के जो है प्रोपैन 1 होल है और प्रोपैन 2 होल है, जो आपके जो टेस्ट करेगा आपके सिलेबस में जो है. दैट्स इट. तो जिनको नामिंग याद नहीं, नेम याद नहीं रखते, तो बस पोजीशन एंड फंक्शनल की एक और एग्जांपल दे दे. ले पोजीशन और फंक्शनल की एक और एग्जांपल. CCC. What is this called? What is this compound called? What is this molecule called or compound? What are these called? Are these two isomers? You don't need to know the differences between the two. Are these two isomers? This is not propane. It is meth prop. It is 1-chloro propane. Done? This one, it's 1, 2, 3. That's the 3 carbon chain, which is propane. But now it's not 1-chloropropane, it's 1, 2, 3. It's 2-chloropropane. So they are position isomers, not functional isomers. Done? Easy peasy lemon squeezy. अच्छा एक और दे देता हूँ, देखिए पोजीशन फंक्शनल ग्रुप की देखिए. CC, hopefully this is right, this is OH, this is COC. बताएं जी. Are these two isomers? Yes, no, yes, no, yes, no. Are these two isomers? Sir, I have a class at 12. बस इसके बाद polymerization खड़गाने लगे. Yes, 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 yes. Can we do one for chain? Absolutely, we can. ये सारे चेन मैंने ऊपर जब आपको नेमिंग सिखा रहा था तो चेनिंग चूनिंग ही कर रहा था, और क्या कर रहा था ये देखिए. ये नेमिंग में आपको क्या सिखा रहा था, ये चेनिंग ही कर रहा था. Where is it? Where is it? Where is it? Right here. This is a chain isomer. This is a chain isomer because I've branched it. These two are position isomers. These two are chain isomers. Yeah. Acha. They are isomers. Why? Because they have the same molecular formula, which is C2H12345 C2H6O, and this is 1, 2, 3, 4, 5, 6 C2H6O. ये आपका alcohol functional group है. Alcohol. This is something else. I don't know what this is. This is ether. Who cares what ether is? Not ester, ether. Nobody cares. But they have the different functional group. Functional group isomerism will not be tested that much, right? मतलब इतने बंदा आंखें इस्तेमाल, listen, their functional group has changed. That's why they're called functional group isomers. They're types of structural isomers. The molecular formula is same. The structures are different now because their functional group has changed. But remember, even the functional group isomerism is not tested that much, but use your brain for crying out loud. This is alcohol because of the OH. This is alcohol. Does this look like an alcohol to you guys? Is this an alcohol? No. So this must be something else, but the molecular formula is the same. Therefore, they must be isomers. They must be isomers because they have the same molecular formula, but different structural formula. How do I know they have different structural formula? For crying out loud, that's alcohol. This is literally something else. It's ether, but who cares? Not same general formula, yeah. Same molecular formula. Same molecular formula, yeah. Yeah. So that's it. This was all there was to आइसोमर से बच्चे पता नहीं कितने डरते थे, कितने ये नाम डिफरेंट होगा आइसोमर्स होंगे. आपके कोर्स में सबसे ज्यादा ब्यूटीन का जो आइसोमर है वो टेस्ट होते हैं. 3 आइसोमर्स है ब्यूटीन के. ब्यूट 1 इन है, ब्यूट 2 इन है और 2 मिथाइल प्रोपीन है, विच इज द चेन आइसोमर्स. नोबडी वांट्स टू डिफरेंशिएट बिटवीन चेन और स्ट्रक्चर. वो बस आपसे पूछेगा स्ट्रक्चरल आइसोमर इसमें कौन से हैं. और फिर आपके अल्कोहल में आपसे सिर्फ प्रोपानोल पूछता है, प्रोपैन 1 ओल और प्रोपैन 2 ओल. अच्छा, मुझे सिर्फ ये बताएं कि मीथेन या इथीन या प्रोपीन इनके आइसोमर्स हो सकते हैं? प्रोपीन का कोई आइसोमर हो सकता है? नहीं हो सकता. मीथेन का कोई आइसोमर हो सकता है? नहीं हो सकता, बिकॉज देयर इज नो वे यू कैन डिफर द नेमिंग. So that's it. That's all there was to your organic chemistry. The only bit that is left is polymerization. That's it. So officially, we're done with everything. I'm giving a break. We're done with everything. Polymerization is left. That's it. And tomorrow, if you want, we can have like a past paper session of organic chemistry. Or what we could do is do moles and stoichiometry. So we can decide that in a while. Let me pause the recording. I'm resuming the recording. I'm resuming the recording because we have to just finish it, right? So let's start off with polymerization. We have to finish it today, no matter what. Polymerization. What is polymerization, or what is a polymer? Basically, in a polymerization reaction, thousands of small molecules join together to make one large, big, fat molecule, right? So these thousands of small molecules, when they are joining together to make this big, fat chunk, big, fat, large molecule, we call this process as polymerization. I'll give you an example. Let me just remove the water droplets on my iPad. I'll give you an example. There's a small unit or a small molecule. It combines with another small unit, which combines with another small unit, which combines with another small unit, and so on and so forth. When many small units combine together, they give you one large unit. In chemistry, these small units, in other words, known as small molecules, are known as monomers. So we say when one monomer joins with another monomer, joins with another monomer, joins with another monomer, it gives me what? It gives me one large unit. And this large unit in chemistry is called polymer. Literally, the mono means single or small, right? So it's a single, and mer means unit. So a single unit. But if they ask you to define a monomer, you say a monomer is just basically a small molecule, right? But monomer literally means, mono means single and mer means unit. So single unit combines with another single unit, combines with another, but they are essentially my small molecules, right? So this one small molecule combines with another small molecule, with another single unit, with another single unit, to give you polymer. Poly literally stands for many. So it gives you many units combined together in the form of one big, fat, large molecule, right? So if I ask you, what are polymers? What are polymers, everybody? Polymers are large molecules. We're not going to call them units, right? We're going to call them molecules. They're large molecules formed. A large molecule formed when many small molecules called monomers join together, right? That's what polymers are, and you need to know this, right? Now, and that is the reason why polymers are also, the other word for polymers is macromolecules. Why do you call them macromolecules? Why do we call them? Because macro means large molecules, one large, big, fat molecule. Adyan, you are very smecksky, man. तौबा 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 आंखें मैंने अब धोनी इंतजाब से ये तस्वीर देखने के बाद तो आपकी सॉरी सॉरी मैन that's this there that's why they're called macro molecules because it's a one big fat giant molecule, right? Now, have you ever seen a polymer in your life? Have you ever seen a polymer? Although we don't know, although we don't know it, but we've seen a lot of polymers like plastic. Polymers are literally all around us. I'll give you the basic example. Plastic is one of the worst thing that has happened to mankind, right? And it's a polymer, right? It's basically polythene. You have keep plastic bags, plastic bottles, so on and so forth, and this is so dangerous and whatnot. We're going to learn all the dangers of plastics, but that's your polymer, right? There's so many polymers in day-to-day life that it's just unlimited examples, right? But since we're short on time, we're just going to dive into the main crux. We're going to dive into the main concepts, right? So then in polymerization, you have two types of polymerization. Number one, there are two types of polymers. Number one, you have like your addition polymers, and then you have like your condensation polymers. And then there are further subtypes in condensation polymers. Let's first focus on addition polymers. What are addition polymers? Addition polymers or addition, what is addition polymerization? Well, in addition polymerization, this polymerization will only take place if the monomers have at least a carbon-carbon double bond, right? So you need to have unsaturated compounds for it. And in our course, the only unsaturated compound that we've studied is our alkenes. So these addition polymers, they form from your unsaturated compound. In other words, they form from your alkenes. When many small alkenes, they join together, they're going to form this beautiful, beautiful polymer, right? So in addition polymerization, you must have, the monomers must have a carbon-carbon double bond, at least one carbon-carbon double bond. But in our course, we're just going to write carbon-carbon double bond because in our course, we only have one carbon-carbon double bond. So monomers must have. It's a type of polymerization in which monomers have carbon-carbon, when monomers which we have having carbon-carbon double bond join together to form one large polymer. Carbon-carbon double. Done. Now, the best example that I could give you of your addition polymer is a polyethene. You guys might be thinking, sir, what do you mean by polyethene? Basically, poly means many. And ethene is the monomer. It is the unit that was used to make this polymer, right? So many ethenes have joined, so many ethenes have joined together to make this polymer. So if I were to draw the structure of polyethene, I could easily do that. Why? Because my monomer, I just have to identify my monomer. My monomer is going to be ethene. Ethene is the small molecules which have joined together and made this polymer. Polymer, why? Because there are now many molecules of ethene joined together. So let's draw our ethene monomer. That's monomer A. That's monomer B. They're all my ethene monomers. Ethene, they're my small molecules of cute ethenes, right? So this is ethene. These are my ethene molecules, which are my monomers. How do I know these are my monomers? Because polyethene literally means many ethenes joining together. So what should the monomer be? The monomer should be ethene. So what happens? It's very easy. The double bond breaks, the double bond breaks, the double bond breaks, and you just add them together. Boom, boom. Now we add them together, but we also show the leftmost bond and the rightmost bond. We show it like this. Why do we show it like this? We show it longer compared to the normal bond. This is basically the connectivity bond that we show. This bond is known as the connectivity bond. Why do we call it the connectivity bond? Well, the reason is that polymers are very large molecules, right? Polymers are very, very huge molecules. A polyethene has almost 34,000 carbon atoms in it. 34,000 carbon atoms. So it's not humanly possible for you guys in a paper of 1 hour 15 minutes or 1 hour 45 minutes. It's not humanly possible for you to draw 34,000 carbon atoms. वरना फिर तो और कोई काम नहीं करेंगे 34,000 carbon atoms बना के. That's why we show these long ass bonds which are called connectivity bonds. Okay, this can go on and on and on and on and on. और ethene line और ethene line और ethene line और ethene line इसको add करने जाए. Right? So this is basically a part of a polyethene that I've shown. This is a part of polymer that I have shown. And how does this polymer form? You do not need to know any conditions for forming polymers, right? You just need to know the structure of the polymer when it forms, right? In this particular case, for addition polymers, no conditions are required. Huh? you provide a high temperature, you provide a high pressure, you provide catalyst, which is basically like Ziegler-Natta catalyst usko kehte hain. It's triethyl aluminum and titanium कोई tetrachloride होता है. Nobody cares, right? You just need to know how to make the structures of these addition polymers, right? Now, the problem with addition polymers is bracket लगा दें, जरूरत नहीं है bracket की. The problem with addition polymers is that this polyethylene, can I derive a general formula for this polyethylene? I can never derive a general formula. Why? Because I can never know how many carbon atoms will there be present. I can never write the exact formula. If I can never write the exact molecular formula, I can never have a general formula, because the general formula, sir, kindly write the name of the catalyst ले लें यार, but नहीं है आपके कोर्स में, नहीं है. Ziegler, yeah, but it's not in the course, not in course. High temperature, high pressure, a catalyst which is Ziegler-Natta, nobody cares, not in course. Okay, great. So what happens is, because you cannot write the exact formula, therefore you cannot find a general formula, because the general formula is the molecular formula is in term of n. If you can't write the exact molecular formula, how will you get a general formula? Then what do? We say, okay, if I want to draw a polyethylene, what do? I know that my monomer is going to be ethene. That's my monomer. And how many monomers would I have? Now, your chemistry book obviously says that, chemistry book and your industry also says that you can have up to 34,000 carbon atoms, which means how many monomers would you have? 34,000 divided by 2, I get 17. It means you would have 17,000 ethene molecules approximately, right? It can be more, it can be less. So we say, hey, you can have 17,000, 30,000, 40,000, whatever you would have, you will just represent it with n. What does n mean? N means the number of monomers. It stands for the number of monomers. So you can have lots of monomers, because you cannot identify the exact number of monomers that will be present. Therefore, what we do is, let me just unmute everybody, mute everybody, sorry. So because we cannot fixate the number of monomers that you're going to have, you just represent it with n. What does this n stand for? This n stands for the number of monomers. We tell the examiner it can be any number of monomers, right? And once it forms a polymer, how will it form a polymer? Well, you heat it, you provide pressure, and you provide a catalyst. Nobody cares. But you provide a pressure, you provide a catalyst, and what would happen? The double bond would break. So the double bond breaks. These are the bonds. So if the double bond breaks, now this carbon, if the double bond has break, this carbon has now made 3 bonds. This carbon has now made 3 bonds, right? So they can all make more bonds, and we represent the connectivity bonds right here. So once we represented the connectivity, now you had n number of monomers. So how many monomers would you end up? How many monomers would there be in the polymer? If you had 10,000 monomers here, you would have 10,000 monomers joined in this polymer. If you had 20,000 monomers here, you would have 20,000 monomers joined in this polymer. Since you have n monomers in this polymer, therefore you would have since you have n monomers right here, therefore you would have n monomers in this polymer. So that's a general way of writing a structure of polythene. Acha, how many monomers are here? Can you tell me how many monomers are this? 1, 2, 3. These are 3 monomers, also known as 3 repeat units. So sometimes the examiner says, draw 3 repeat units, draw 2 repeat units. He's calling it a repeat unit because if you notice, after every 2 carbon, the entire structure is repeated. After every 2 carbon, the entire structure is repeated. The entire structure is repeated. That's why he is also calling it as repeat units, or he can also say draw 3 monomers. Reduce the structure of repeat unit. Chill, man. I've not taught you any guys. So let me just finish polymers properly, and then you guys can ask me as many questions as you want. Now let's draw structures. Bas khatam. Addition polymers finished. Let's draw the structures. Let's do some examples. So sir, how do you do some examples? How do we do some examples? Basically, let's draw like our polypropene. We want to draw polypropene. How do we draw polypropene? That's the question. But polypropene se pehle, let's look at the simple example. Polychloroethene. I want to draw polychloroethene, which is also known as PVC, polyvinyl chloride. Sir, where did the double carbon bond go? The double carbon bond disappeared. It broke. The double bond breaks. And these are the connectivity bonds which form. Why does it break? Because of heat, high pressure, and a catalyst. And that's how plastic is formed. This is basically your plastic. Okay, let's draw polychloroethene. Can we draw polychloroethene? Absolutely. We know what the monomer is. What's the monomer? It's chloroethene, because polychloroethene means many chloroethenes. Can we draw chloroethene? Absolutely, we can. This is my ethene molecule. Chloroethene means it should have one Cl bonded to it. Now, the examiner is saying, maybe the examiner is saying, draw like 2 repeat units. 2 repeat units mean what? You're going to repeat this structure twice. So I'm going to draw this structure and I'm going to copy this and paste it again. So we paste it right here. What happens? The double bond breaks, the double bond breaks. These two will join together right here, and these are my connectivity bonds. That's it. Because the examiner is saying draw 2 repeat units, you do not need to put any brackets and any ends. You do not need to do any of that stuff. Why? Because the examiner is already told to draw 2 repeat units. Don't draw me like 10 repeat units, or just don't draw me. If the examiner just says, okay, draw for me polychloroethene, and he does not tell you the number, he does not specify the number of repeat units, he does not specify the number, then the minimum number you should draw is 2. But if you don't want to draw it, you can simply just draw the general way of drawing it. So chloroethene is this. You are going to have, let's suppose he has not specified the repeat units, so we are going to say we're going to have n repeat units, and then once polymerization takes place, the double bond is going to break. These will become the connectivity bonds, and you're going to put n. Why? Because if you had n monomers here, you would have n monomers joined in the polymers. Done? So that's polychloroethene, also known as PVC. PVC is used in a lot of places. Yeah, PVC ki bahut use hai. It's like uski properties are it's strong, hard. You use it in in window frames. आपके घरों में window frames में, pipes में, electrical insulation में इस्तेमाल होता है. Sir, if it is mentioned, so can we mention the specific number on the place, or we have to write n? No, if he says, okay, draw 2 repeat units, so then you have to draw 2 repeat units. No need for any n, or no need for putting any bracket and writing 2 here. You've already drawn 2 repeat units. The structure repeats itself after this. This structure is repeated right here. So there are 2 repeat units. If he says, just draw polychloroethene, then you have to write it in the general way. If he says, usually 99% of the time, he's going to say, draw 2 repeat units or 3 repeat units. If he does not specify, then you draw it in a general way. If he does not specify it, you can also just draw 2 repeat units. Unless he says something, yeah, you drew it that way. So do you have guest papers? Maaf kar do, bol to diya hai guest papers. My guest paper is on the portal. You can purchase the portal from Noor. Thank you very much. Okay, so that's polychloroethene. Can we draw like maybe like poly tetra, polytetrafluoroethene. Oh my God, polytetrafluoroethene. Sir, ethene, which means polytetrafluoroethene means that tetrafluoroethene is going to be my monomer, right? So what is tetrafluoroethene? Ethene is this right here, and tetrafluoro means it has 4 Fs. Tetra stands for 4, so it has 4 Fs. F, right? So if you want to, let's say the examiner is saying draw 2 repeat units. So if the examiner is saying draw 2 repeat units, I'm just going to copy this. I'll copy the exact same structure, and I'm going to say, hey, the double bond breaks, the double bond breaks, the double bond breaks. Now these 2 carbons are making 3 bonds each. Therefore, they're going to make the new bond right here with each other. They're going to join together, and these are my connectivity bonds. Done, peeps? Okay, what if the examiner says draw polypropene? Acha, one more thing. Once you have a polymer, you can easily, in addition polymers, how do you go back from an addition polymer into its monomers? Let's suppose you're given this particular polymer right here. How do you go back into its monomer? You put a cut after every 2 carbons, put a cut after every 2 carbons, put a cut after every 2 carbons, and put cuts at the connectivity bonds. Put a cut after every 2 carbons, put a cut after every 2 carbons, put a cut, and between 2 cuts, you're going to have your monomer. Between 2 cuts, so they're all the same things, right? So between 2 cuts, what's my monomer? It's C bonded to C, bonded to H, bonded to H, bonded to H, bonded to H. And obviously these connectivity bonds are going to go back here to make the double bond. So this was the monomer, which was ethene. So this was polyethene and the monomer was ethene. If you check this out, can we find the monomer? Put a cut after every 2 carbons in the straight chain. So put a cut, boom, boom, boom. Between 2 cuts, you're going to have your monomer. That's my monomer. That's my monomer. And you're going to make the double bond right here. So how do you make the monomer? C bonded to C, H, H, Cl, H. And obviously this double bond was broken, so it'll form again. Done. Similarly here, if I were to find the monomer, you put a cut after every two carbon, put a cut, put a cut. This is my monomer, that's my monomer, and you just put the double bond where it was. The double bond which broke, you basically put it back, right? So C, C, that's F, 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 and the double bond forms again. So this was the monomer. Done, peeps? Now, let's draw polypropene. Now, I'm not going to go into the detail of why we are doing certain things. There's a lot of concept and logic to it, but who cares? You can derive it for yourself or you can ask me later on. But how do we draw polypropene? Propene is basically C bonded to C bonded to C, right? That's propene. Now, when you are drawing these addition polymers, you have to make sure that everything is around, above, or at the bottom of these two carbons. The double bond, everything would be around the carbon-carbon double bond. So you're not going to draw it in a straight chain. Rather, whatever is bonded to these carbon-carbon double bonds, they're going to go at the top, at the bottom, at the top, at the bottom of these double bonds. See, this carbon already has two bonds. These are the hydrogen bonds right here. That's the hydrogen bond. That's the hydrogen bond. The rule says, although there is a lot of logic to it, but the rule says that instead of drawing it in a straight chain, you're going to take this CH3 and you're going to place it at the bottom. You're going to take this bond and place it at the bottom. Everything should be above or below the carbon-carbon double bond. So the only thing in the straight chain should be in between the carbon-carbon. The only thing in the straight chain that should have been present is the carbon-carbon double bond, right? These should be the carbons in the straight chain. Everything else will either go above it or below it, right? And the reason for that is pretty simple, is to go back into its monomers, right? If you, I'll tell you a little, right? So if I leave this as it is and I want to make like, a polymer out of it, so the double bond breaks, this is the new bond that forms, and that's the polymer. How do you go back into the monomers? You put a cut after every two carbons. Dude, if you put a cut after every two carbons, this will tell you that the monomer is ethene, although the monomers was propene. But if you do not get this, it's okay. So to successfully go back into its monomers, we have to do this. If you don't understand what I just did, you just need to know that the everything when making an addition polymer, everything should go above and below the carbon-carbon double bond, right? Yes, you need to follow this rule. If you don't, you're going to mess it up, because every single time when you make an addition polymer and you want to go back into its monomers, you're going to end up with ethene as the monomer. So what am I going to do? I'm going to take this CH3 and draw it right here, because this is the carbon which this CH3 is bonded to. So my monomer should look something like this. I'm going to rearrange it. We rearrange it. Now, if I want to draw polypropene, I can easily do so. How? I'm going to duplicate this, copy. I'm going to copy and paste this right here. I'm going to copy. If they say draw 3 repeat units, let's draw 3 repeat units, right? So it's 1, 2, 3. Double bond breaks, double bond breaks, double bond breaks. That's the bond, and these are my connectivity bonds. That's it. And see, now if I want to go back into my polymers, put a cut after every into my monomers, we put a cut after every 2 carbons in the straight chain. Put a cut, put a cut, put a cut. Look at this. Meth, eth, prop. Yes, sir. We ended up with propene. So you draw the same structure as it is. If you want to go back into the monomers, you draw the structure as it is and just put the double bond back. The double bond that you broke, you put it back. What about butene? Let's do butene. Let's suppose we want to make a polymer out of butene. Let's suppose we want to make polybut-1-ene. And let's suppose we want to make a polymer which is polybut-2-ene, which was tested in O levels. So in O levels, the difficulty level is such. In IGCSE, it's not that difficult, but in O levels, they also make you, sir, do I need to put a bracket after a polymer? No. I'm making, the examiner is saying make 3 repeat units. These are the 3 repeat units. These are the 2 repeat units. If the examiner says just make the polymer, then N monomers, and therefore the bracket to write the N right here. But usually the examiner will tell you draw 2 repeat units, 3 repeat units, 2 repeat units, 3 repeat units. No need to draw any brackets, no need to put any N, because you put N where you know that you do not have the exact figure of the number of monomers that you need to have. That's why we put N, because N represents the number of monomers, right? Okay, polybut-1-ene. Let's draw polybut-1-ene. So let's first draw the structure of but-1-ene. That's but-1-ene right here. Literally. That's bonded to hydrogen, and that's CH2, CH3. So what am I going to do? I'm going to take this CH2 and CH3 and I'm going to plug it right here. Everything should be above and below the carbon-carbon double bonds. So I'm going to rearrange it for myself. This is H, this is H. That's the H. और इसको बेहतर है, इसको H को मैं नीचे लिख रहा हूँ. That's the H. And that's the C. कितने C's हैं? 2 C's and 1, 2, 3, 4, 5. 2 C's and 5 carbons. So C2H5. So now we're going to make a polymer out of it because we've rearranged it. Now make the polymer, please. Paste it. You draw 2 repeat units or 3 repeats. Let's draw 3 repeat units. So paste it, paste it, paste it. Exact same. Yeah. This is the bond, the double bond breaks. These are the bonds that form, and these are my connectivity bonds. That's literally it. Literally. That's polybutene. If you want to make polybutene, let's check this out. Acha, if I want to go back into my monomer, how do I know it's polybutene or Acha, pehle ye banate phir main batata hu. Wait. Let's make this first. Polybutene. First, draw the structure of butene. Meth at the proper but. Right? So that's my CH3. अच्छा ऐसे अगर नहीं अच्छा लग रहा तो लिख लें, ऐसे लिख लें CH3 CH3, right? So what am I gonna do? Everything should go above and below the carbon bonds. So this carbon is already bonded to this hydrogen, the carbon-carbon double bond. So right, so if this carbon is already bonded to this hydrogen, this will be rearranged. This will go right here at the buttock. This CH3 will go right here at the buttock. So if I want to rearrange this CH was right here, this CH was right here, and the CH3s will go right here at the buttock. The CH3 will go right here at the buttock. And it says draw 3 repeat units. So you just copy this and you like paste it. You like paste it again. The double bond breaks, the carbon-carbon double bond breaks, double bond breaks, double bond breaks. And this is the new bond which forms, this is joined, and these are my connectivity bonds. Yeah. Okay, time to kick Adyan out. Adyan, sorry, man. I have to kick you out, bro. Adyan, because you disturbing, man. You disturbing too much. Okay, bye, Adyan. See you later, alligator. You're sorry? Okay, then it's fine. But Adyan, please. ASY, I'll kick you out too, man. Chill out. That's why I don't do free sessions, right? The problem with these free sessions is that people are then non-serious. So इसलिए हमारे professor हमें कहते हैं never sell anything for free because people can obviously because of such people, I always see because of you guys, those students who are actually in need, who can actually not afford such premium classes, they are put at a disadvantage. Thank you for apologizing for Adyan and ASY, man, everybody. Chill out, please. You're taking away from the students who actually need help. Okay. So now, if I were given these two structures and I were to say, what is the monomer? Look at the monomer. It's very easy. You put a cut after every 2 carbons, put a cut after every 2 carbons, put a cut after every 2 carbons. Look, between 2 cuts, you're going to have the monomer. This is between 2 cuts. Draw it. Draw the structure as it is. Draw the structure as it is. C2H5, and then just put a double bond. Hanji, what is the monomer? Meth, ether, proper, but. Start numbering from the side where the double bond is the closest. 1, 2, 3, 4, right? So what is the name? It's butene, polybutene. And let's draw the monomer for this. Put a cut after every 2 carbons in the straight line. Put a cut. Between 2 cuts, you're gonna have your monomer. So that's my monomer. हाँ बताएं जी, is this butene or butene? Butene or butene? C bonded to H, draw the exact same structure and then just put a double bond. बताएं जी, butene, butene. See, that's the proof. Meth, eth, pro, but, right? Start numbering from the side where the double bond is the closest. Is at the same length from both sides. 1, 2, 3, 4. So this is known as butene, but what's the position of the functional group? It's between 2 and 3. So butene. So this is mostly tested in O levels, but this time I reckon such polymerization might also be tested in your IGCSE. अब चूंकि IGCSE और O levels तकरीबन same हो गया, but I also am reckoning that this time condensation polymers will be tested because पिछली दफा भी addition हो गए थे. But see, that's very easy. It's very easy to draw addition polymers. We're done with addition polymers. That's literally it, literally. And they all have certain uses. Polyethylene is used in plastic bags, gloves. Actually, let's talk about like a little, let's talk about polyethylene for a moment. Let's talk about polyethylene. What are the uses of polyethylene? It's used in plastic bags, gloves, क्लिंग फिल्म, राइट? वो जो आपका क्लिंग फिल्म जो अम्मी जो है बचपन में डालती थी, whenever we would have our lunch boxes, she used to put like cling film around it so that it does not get it is a good insulator. Plastics are insulators, right? So it used to insulate that heat, and the not the foil, aluminum foil is something else. Cling film is the plastic type thingy, right? So if they ask us to draw two repeats unit, is it fine to draw it like this? Yeah. What, you're sending a picture? Dude, you have to mention the hydrogens in it. If it's polyethylene, yes, then it's fine, but you cannot just draw. Please, you guys cannot just draw it like this. Yeah, you have to show the examiner H, 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 H. You get 0 mark if you don't show the H's. Examiner को क्या पता है कि आपने जो डंडे बनाए ये क्या है? Okay, so these are certain uses of plastic, but there's also a problem associated with plastics. What's the problem associated with it? जनाबे वाला plastics और polyethylene are non-biodegradable. Degradable. What do you mean by non-biodegradable? Non-biodegradable are substances which cannot be broken down, by the action of bacteria or decayed by fungi, right? Cannot be broken down by organisms, or you could say cannot be broken down, yeah, cannot be decomposed by bacteria, or you could also say cannot be like decayed by fungi. इसमें कोई चीज भी याद रख लेना. So, non-biodegradable are substances which cannot be broken down by bacteria. Plastics are non-biodegradable. Acha, why are they non-biodegradable? Not in your course. But if you use your brain a little bit, see, here basically what happens is you have carbon-carbon single bonds, and carbon-carbon single bonds mean what? They're chemically unreactive. Alkanes are also saturated, right? Why are alkanes chemically unreactive? Because they're saturated. They have carbon-carbon single bonds. Similarly, when a polymer forms, it's such a huge structure with carbon-carbon single bond that is so stable, right? So because it's very stable, we can say that it's generally chemically unreactive. So why are plastics non-biodegradable? It's not in your course. But if it comes, you say that it has the carbon-carbon double single bond. That's why they're chemically unreactive. Why are they chemically unreactive? Because of the carbon-carbon single bonds, essentially, right? Effectively. And there's also one more thing. It has no active site. What do you mean by active site? Well, you've studied, this is for bio geeks. You studied this in bio, that in order for something to be broken down by bacteria need to be attached to it. And bacteria, there must be an active site on it. And only if there is an active site, the bacteria will go there, a complex will form and it will break it down, right? But if there is no active site, the bacteria will not be able to bond with it and break it down. Similarly, the fungi will not be able to bond with it and break it down, right? So it has no active site, so the bacteria can not bond on it. But this is just extra information. This has never been tested. Okay, why are these polyethylene addition polymers non-biodegradable? They say, what do we mean by non-biodegradable? But they've never asked why are they non-biodegradable. Sir, were you bio students? No. Sir, is there any way to make them carbon-carbon double bond so that they react and biodegrade plastic solution? Then it's not going to be plastic for you, right? Omama Rahman, that's a good idea, but that's not going to be called plastic, right? Plastics are formed like this. This is the structure of plastic. So could you read the third point? Which third point? These type of polymers in which you have the double bonds in the polymer structure, you'll study that in A levels. No active site. Chemically unreactive, decayed by fungi. Yeah. And because of this problem, that they are non-biodegradable, there are certain inherent problems related with plastics. What are those inherent problems? Number one, they basically, there is the disposal in landfill sites. What do you mean by landfill sites? Landfill sites are areas of land that is used to dump rubbish. Oh, dude, if you dump plastic in these areas, plastics are non-biodegradable. You are going to use up that land. That land will never be used for agriculture purposes. That land can never be used for construction purposes because you've dumped all the plastic there, which is non-biodegradable. Some of you guys might say, sir, why not just burn it? That is the stupidity of human beings. That is the stupidity of our government as well, that we are burning it. Well, sir, if you burn plastic, they're going to release toxic gases. So it results in the formation of toxic gases. जज्बा आ गया मेरे में. हाँ, सच एज मेथेन वगैरह, ग्रीन हाउस गैसेस भी आते हैं, कुछ सल्फर के सल्फर कह रहा हूँ, ग्रीन हाउस गैसेस आते हैं, कुछ कार्बन डाइऑक्साइड, कुछ मेथेन, कुछ अदर टॉक्सिक गैसेस. सो इट फॉर्म्स अ लॉट ऑफ टॉक्सिक गैसेस डिपेंडिंग ऑन द composition. So formation of toxic gases from burning, right? And the third disadvantage is our entire marine life. Our entire marine life is at is at their lives are endangered because of this, because you take these plastics, you throw it in these oceans, and they accumulate in these oceans, they get stuck in fish gills, in the turtles, and in like sharks, and they eat it and whatnot, and then they cannot breathe properly, and then they die. Yeah, so it results in the death of marine life. Why? Because these plastics accumulate in oceans. So the accumulation of plastics in oceans is deadly to what? For the aquatic life, yeah, to the marine life. They can get stuck in fish gills and all of that good stuff. Yes, कार्बन डाइऑक्साइड भी रिलीज होता है, कुछ हद तक मीथेन भी रिलीज होता है, बहुत सी चीजें रिलीज होती है, बट टॉक्सिक गैसेस भी रिलीज होते हैं, अनबर्न्ड हाइड्रोकार्बन्स भी रिलीज होते हैं, सूट भी रिलीज होता है, बिकॉज इट्स सच अ ह्यूज चेन. रिमेंबर, इट्स सच अ ह्यूज चेन. वो काला काला धुआं, इफ यू बर्न प्लास्टिक, ऐसे काला काला धुआं नजर आता है. हाँ, वो भी हो सकता है मोहम्मद अहमद, यू आर एब्सोल्युटली राइट. बहुत सी गैसेस निकल सकती है, राइट? यू डोंट नीड टू नो द इन्फॉर्मेशन अबाउट गैस. इफ यू वांट यू कैन सर्च इट अप. तो इसलिए फिर हम क्या कर सकते हैं? वी जस्ट रिसाइकल द प्लास्टिक. नाउ रिसाइकलिंग ऑफ प्लास्टिक हैज बीन रिमूव्ड फ्रॉम योर कोर्स. So what we do is we recycle plastic. How do you recycle it? You collect these plastic. वो जो कबाड़ी वाला आता है चाचा, उसकी बहुत इज्जत किया करें. He is protecting you guys from all of this. He collects the plastic. He takes it to the factory where plastic is separated. And once plastic is separated, it's melted. And once you melt it, it's treated to make new products. So that's the recycling on process. I'm not going into detail because it has now been removed. So it's treated to make new products. But that's the process of recycling. So what happens? You collect them first, the chacha, he collects them, then it's separated in these factories into according to different chains, and then it's melted and then it's molded into different shapes, right? So just recycle them. Which means कि अगर आज प्लास्टिक से मैंने बर्तन बनाए हुए हैं, तो कल को इसी को मैं खराब हो जाए तो इसी को बजाय ये कि आई मेल्ट इट एंड आई अक्यूमुलेटेड, जस्ट इसी को रिसाइकल करें. डोंट मेक मोर प्लास्टिक, रिसाइकल द एग्जिस्टिंग वंस. अब जो गंद मारना था वो ह्यूमंस मार चुके हैं. And that is why nowadays what is happening is people are also, and you can see this in Pakistan nowadays, they charge you for the bags that you use. You know, हमारी अम्मियाँ जब शॉपिंग करने जाती वो कहती 30 बैग चाहिए. हर दफा सवाल पूछते हैं बैग चाहिए. वो बैग चाहिए इसलिए कहते हैं बिकॉज इट्स नो लॉन्गर मेड फ्रॉम प्लास्टिक, इट्स मेड फ्रॉम सर्टेन डिग्रेडेबल मटेरियल. हाँ, सर्टेन आर ऑल्सो मेड फ्रॉम प्लास्टिक. सर्टेन प्लास्टिक्स नाउअडेज आर ऑल्सो डिग्रेडेबल. डिग्रेडेबल प्लास्टिक्स आ गए हैं दुनिया में. What are those degradable plastics? Why are those plastic degradable? Sir, they are biodegradable because certain plastics, they contain additives. Additives का मतलब कुछ चीजें इसमें ऐड की जाती है, कुछ केमिकल ऐड किए जाते हैं. And those chemicals, like for example, आजकल का जो एक प्लास्टिक आया हुआ है, it contains additives such as starch. And because it contains starch, the bacteria can feed on this starch to break it down. So we call this type of plastic as biodegradable. So now, although plastics are not biodegradable, that's the huge problem. But nowadays, there are certain biodegradable plastics that have been developed. Right? Degradable. Is the spelling of degradable correct? I think it's Gradable, right? Or Eable. I think E or A. Okay. And certain plastics now also contains certain additives, certain other chemicals, which basically helps those plastic break down by by just exposing it to sunlight. So अब ऐसे कुछ plastics आ गए कि if you expose it to sunlight, they are going to break down, right? So if you expose it to sunlight, they are going to break down, and such plastics are now called photodegradable. So what are photodegradable? ये कभी टेस्ट नहीं हुए ये कॉन्सेप्ट, हालांकि आपके कोर्स में है, ये अल्फाज नहीं है, लेकिन you should know this कि certain plastics nowadays are biodegradable, which means they can be broken down by the action of bacteria, and certain are also photodegradable because photo literally stands for light. They can be degraded by light. But this entire thing is not in your course. I'm only teaching this to you guys. If a question comes, what do you mean by photodegradable, which is not going to be tested, but if it comes, you should know that photodegradable means that certain substances which can be broken down by photo, which can be broken down by light. That's it. Can you scroll up a bit? Sure. We're done with addition polymers. Finished. Condensation polymers left. Okay, before we finish, let me just write certain properties of plastics. What of these plastics, right? Number one, it's a good insulator. You can use it in electrical appliances. It also has advantages, right? It's a good insulator. You can use it as in electrical appliances. It's a poor conductor of electricity as well. So you could use it in electrical appliances. It's a poor insulator, so you could use it in electrical appliances where there is a problem of heat. You don't want it to heat up that much, so you could use it there. They're unreactive. इसको मैं लिख लेता हूँ. They're unreactive, which means that they're not gonna be affected by air, acids, water, and all the other chemicals. So you can store certain substances in it. You could store food in it, right? So you can store food in it because they're unreactive. They will not आज ये प्लास्टिक की डब्बियों में खाना इसीलिए डाल. So there are certain advantages of it as well, right? They're also lighter compared to wood. मतलब अगर wood या metal, आप किसी metal की plate ले, plastic की plate है, so they're lighter to carry. So you also have certain advantages of them, yeah? Lighter to carry. Actually, my question, will it have a high melting point and boiling point or low? It's a macromolecule. It'll have all the properties of macromolecules. It'll have a high melting and boiling point, right? It's a large structure. It's a macromolecule, a big fat molecule. Yeah, and they do not catch fire easily as well, because when you heat them, they often what happens is they often become soft and they melt, right? हाँ, वो काला हो जाता है, some char, some char किसको कहते हैं? वो काला काला जब हो जाता है. But they do not catch fire easily. So these are certain properties. It's insulator, so can be used, and poor uh, conductor of electricity, and an insulator. Plus, it's an insulator, so it can be used as in electrical appliances and in for insulations. Remember in ATP, you do this particular experiment where you want to find the temperature change, and we say perform this in polystyrene cup. Polystyrene क्या है basically? It's your insulator. Which gas? Sir, ये macromolecules के हैं advantages या polyethene के? नहीं, these are advantages of polyethene. Polyethene here. Polyethene and all the addition polymers. ये addition polymers के advantages हैं आपके course में. Addition polymers. Addition polymers are this. Because usually all the addition polymers, they are used to make plastics. Next, condensation polymers. Khatam. Do we take a break of 5 minutes? I'm tired, yeah. Condensation polymers. Sir, FSY doesn't understand when you have to add the brackets, but he's too shy to ask. Dude, you don't have to add the brackets when he says draw 2 repeat units, 3 repeat units. Why do you have to add the brackets? Matlab, what's in the brackets? You don't have to add any brackets whatsoever. Until and unless you don't know the number of repeat units. So if you don't know the number of repeat units, then you say you have n monomers. Therefore, the polymer that's going to form will have n monomers being joined together. Why else would you need brackets? आप कह रहे हैं इधर लगाऊं brackets, मर्जी है यार, इधर लगाने मर्जी है, लगाएं या ना लगाएं. There's no need to draw any brackets here. If you want to draw it, draw it. If you don't, you don't. No need. Now FSY understands, great. Sir, condensation शुरू करने से पहले एक बार शुरू से notes scroll कर दें, SS लेने हैं. Notes share हुए हैं, हुज़ैफा साहब. Notes are being shared in the IGCSE discussion forum. They are shared. So I'm going to pause the recording for a moment. I'm tired, man. I'm tired. Seriously, I'm tired. Pause the record. Seriously, man, I've gotten so tired. Like, so tired. My head is hurting. But let's start, yeah. Just one last go. Okay, one last go. Condensation polymers. What are condensation polymers? Or condensation. What is condensation polymerization? You need to know how to describe it for the examiner. Condensation polymerization is a type of polymerization in which monomers react together to form a polymer. Sir, Even in addition polymerization, this took place. Yes, monomers react together to form a polymer, but you need to understand there's a beauty about condensation polymers. And that beauty is form a polymer. In condensation polymer, it not just forms a polymer, it also forms another small unit, right? Another small molecule. So in which monomers react together to form a polymer and another small molecule. You need to be able to replicate this in the reproduce this in the exact same way. Because this time I reckon condensation polymers will be tested. H2O in some cases, yes, it can be H2O, it can be HCl. In your course, it's just H2O, but you have to say small molecule. You can't say another water molecule because it's not necessarily water, right? This is how the syllabus is describing it, so it's better to stick to how the syllabus describes it. Small molecule can be HCl, H2O, it depends, but in your course, it's always going to be H2O. I hate condensation. It's so weird. It's going to be very easy. Now, in condensation reaction, there are two more types. Remember, and esterification was actually a condensation reaction in which basically units in which these alcohols and carboxylic acid, they join together to form a larger unit, or to form an ester, not a larger unit, to form an ester. Carboxylic acid and alcohols, they join together to form an ester, and they also made a small molecule which was H2. So it was a condensation reaction. This is condensation polymerization. Condensation polymerization is in which these monomers react together to form a polymer and another small unit. And that was a condensation reaction. Esterification is condensation. And note one more thing, guys. Esterification is reversible. Although we represented it with a forward arrow, we shouldn't have represented it with a forward arrow, but it's a reversible reaction. Let me write it here. Sorry, my bad. This is the last bit. हर अंग अंग मैंने पढ़ा दिया. अंग अंग ang 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 sang. So I've literally taught you guys everything, not left anything out. So it's a reversible reaction, esterification, right? Let's move forward. So in condensation polymerization, there are further two types. One is the synthetic polymerization, and the other one is like natural condensation polymers. In synthetic, we look at like our nylon. Nylon is a synthetic polymer, and we have terylene, which is synthetic, which is also known as PET, polyethylene terephthalate. You do not need to know the full form of this. Natural polymers, it's basically like your fats, your starch, and like your protein, right? Fats and starch have now been removed from your course, but I'll still touch upon them in a while. Nylon, terylene, and protein are only there. Now let's first look at synthetic polymer. What do we mean by synthetic though? Synthetic means they are man-made. They're man-made condensation polymers. If they say, what do you mean by synthetic? Synthetic means man-made. हमने इंसानों ने ये nylon बनाया. Nylon, we use it in our beautiful clothing, fabrics, fishing nets, fishing ropes, and all of that stuff. So we use nylon. It's man-made condensation polymers. That's what synthetic means. Natural means Allah Ta'ala ne banaya. It's not man-made, right? Now, let's first look at nylon 66. Sir, why did you use the word 66? Well, you can call it nylon 66, or you could just call it nylon. You need to first identify the monomers. In order to make a polymer, a condensation polymer, you need to identify the monomers. The monomers for nylon is a dicarboxylic acid and a diamine. Dicarboxylic acid means that you're going to have a C double bonded to the O, which is bonded to the OH. That's the carboxylic acid functional group, dicarboxylic acid. That's the carboxylic acid functional group. And because it's di means two. So you're going to have two carboxylic acids, right? And there are going to be some things in between them. There are going to be certain things in between them which will connect, which will connect these two carboxylic acids, right? So certain things will be in between them, and we represent those things with a box, right? But before I draw the box, I'm going to show you what's present inside. Diamine means, amine is the NH2 group, right? Amine is the NH2 group. So diamine means you're going to have two amine groups. And obviously, they will be connected somehow with certain other atoms. That is the reason why it's called nylon 66. That is the reason why it's called nylon 66. Why is it called nylon 66? Because this diamine is going to have 6 carbons in between them. So this diamine, it has 6 carbons in between them. So carbon, 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 and that's bonded, right? And these are my CH2, 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 CH2. इसका असल नाम है 1,6-diaminohexane. Who cares? Nobody cares, right? But these are all, so now scientists thought to themselves, yeah, why do I have to draw these 6 CH2s again and again and again and again? So they sandwiched this inside a beautiful box. That's why we call this diamine. In this box, you guys know that there are 6 CH2s. That's why it's also known as nylon 6, because this monomer has 6 carbons. This monomer, why is it called 66? Because the dicarboxylic acid also have 6 carbons, including these two. So these two are already present. How many more should you have? 1, 2, 3, 4. 4, not 6, 4, right? Why? Because 2 are already here. 1, 2 are already here. 1, 2, 3, 4. These are 4, right? So it has 4 CH2s in between. That's why you can call it nylon, or you can also call it nylon 66. Why can you call it nylon 66? Because now you know in between these two carboxylic acid functional groups, you basically have 4 CH2s in it, right? इसका असल नाम जो है, it's basically like your hexane dioic acid, but who cares? So instead of writing the CH2 again and again and again, you just sandwich this into a box, right? And if you wanted to write the structure form, nowadays the examiner is doing this. For me to tell you this, these are the two monomer A, monomer B. So now if you draw the two monomers, COOH, bonded to a box which is bonded to COOH. Now you know this is a dicarboxylic acid, means a carboxylic acid here and a carboxylic acid here, and you know what's present inside this box. You know, we used to think when we were little, okay, what's inside this box? Now we know what's inside this box. So that's here. And for amine, देखिए you have to shade one box and you don't, just to show differentiate between them, right? Here you have 4 carbons, here you have 6. Just to differentiate between them, you just shade one and don't shade the other one, right? It's your choice, whichever one you want to shade. Usually it's totally up to you. Okay, so that's one monomer, and that's my second monomer. Now that you have monomers, it's a condensation polymer. What's inside the box? Nobody cares. Here you have 4 carbons inside the box, here you have 6 carbons inside the box. Now what's going to happen is you take these two monomers, the examiner says draw one repeat unit. So monomer number A, monomer number B, what's going to happen? Because it's a condensation polymer, condensation polymers mein kya hote hai? Monomers are going to join together, and how will they join? By eliminating a small molecule. We know the carboxylic acid loses the OH and the amine loses the H. The carboxylic acid loses the OH and the amine loses the H, right? So just make them lose it. Lose it. Remember, carboxylic acid always loses the H. So they are going to lose the H, and this OH goes, this OH goes, and voila, we show our connectivity bonds. This is nylon 66. Can we just memorize the structure? It's gonna be very, very problematic for you, Ayman. Ahmad Shahzad. So this is literally the structure of polymer. This is literally the structure of nylon 66, or just you could just call it nylon, right? And nowadays what the examiner is doing is he's basically writing its structural formula. So COOH वो ऐसे लिख लेता है, बीच में आपको दे देता है CH2, वो हम इंशाल्लाह कल प्रैक्टिस करेंगे, समझ आ जाएगी. बीच में आपको दे देता है CH2 whole 4 times. He's basically saying there are 4 CH2s, and then he gives you something like this, COOH. Tell me what is this? This is literally, he's basically expanding the box for you. That's why I had to tell you what's present inside the box, so that you could easily ignore all of this crappy stuff and note that there are dicarboxylic acids. So whatever is present inside is just the box. So he basically elaborates the box for you sometimes now in the MCQs. Like diamine, what he does is he writes it like this for you now in the MCQs. What monomer is this? So if it's he writes it something like this, CH2, and you had 6 CH2s here, and then you have NH2. So he writes it in the form of a structural formula. So obviously this is the box that he's elaborated for you, right? So it's NH2, NH2. It's a diamine, dicarboxylic acid. Obviously these were the monomers for my nylon, right? Great. Now, and you need to understand that nylon is also known as a polyamide, a synthetic polyamide. Why synthetic? Because it's man-made. Why amide? Because this is the amide linkage that forms the CONH. This CONH, CONH. This linkage is basically called the amide linkage. So if the examiner says draw a circle around the amide linkage, that's the amide linkage right here. So it's a polyamide, but not just a polyamide, it's a synthetic polyamide. हमने बनाया है इसको, humans ने बनाया है, right? And you can also, if you are studying bios in if you're studying bio in biology, you can also call it polypeptide. So in bio, we call it polypeptide. This linkage, we call this linkage as a peptide linkage. This linkage right here is an amide linkage. And because you have so many amide linkages, that's why nylon is known as a polyamide. Poly means many, amide means the linkage, the amide linkage. So many amide linkages. Polypeptide, many peptide linkages. What is the peptide linkage? It's the same thing. It's CONH. In bio, you call it peptide. In chemistry, you call it amide. Both are the same things, right? And you can, and there's also one more thing. You can show the H like this, you can show the H like this. It's your choice, to be very honest. You can show it in the syllabus, it's usually shown like this. So you can show it like this, you can show it whatever, it's your choice. Yeah, I'm just going to keep it like this. I like it like this. Done. Then and what are the uses of nylon? You need to know some common uses. Is like it's used in clothing, it's used in fabric, it's used in like fishing robes, ropes keh raha hu, fishing ropes, and so on and so forth, right? So the best example is clothing and fabric and all of that stuff. Great, we're done with one of them. Oh, how easy. How easy, how literally how easy. So nylon 66 is made up of dicarboxylic acid and diamine. If you know the monomers, you will be able to make the polymer. Huh, 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 huh. Sir Suleiman is making something for you guys. Yeah. Sir, what are you drawing? I'm just drawing something. These are my connectivity bonds right here. Okay, can you guys tell me what are the monomers? What are the monomers? How do you go back from this big fat structure into its monomers? Janabe wala, very easy way, very easy way. Remember in addition polymerization, we were putting a cut after every 2 carbons. Here, what do? We put a cut at the linkage. So there's no need linkage, right? There is no need to rote learn things. There's no need to rote learn. They put a cut at the linkage. We know the linkage is this CONH. That's the amide linkage. Put a cut at the linkage. Put a cut at the linkage. Put a cut at the linkage. And again, right here, right? So between 2 cuts, you will have your monomers. Between 2 cuts. So what is this? This is the dicarboxylic acid. This came from the I'll give it back. It's OH. This came from the dicarboxylic acid. This was the dicarboxylic acid. And literally, that's your amine, right? So NH bond here, that's NH, and it will gain back its H because the carboxylic acid lost the OH, so you give it back its OHs, and the amine lost the H, you gave it by its H, right? So this is dicarboxylic acid, diamine. Which polymer had the monomers dicarboxylic acid and diamine? Your nylon. So that's how instead, you can also from an very easy perspective, in nylon, you will always have the same group on at both sides of this box. So COO, NH. At this box, both the things will be the same. Happens slowly, is very noticeable. Yeah, it is very, after certain practice, you can very easily notice it. But I'm just giving you guys the general way of doing it, right? That's the general way of doing it. So if you want to find the monomers, put a cut at the linkages. Always put the cut at the linkage. That's the general rule of making it. Done? The next synthetic polymer is basically like your terylene. Terylene, also known as PET, polyethylene terephthalate. You don't need to know the full form of PET. It's just polyethylene terephthalate. What are the monomers? The monomers, one of the monomers is the same. It's dicarboxylic acid for terylene, and it's instead of a diamine, it's diol. What do you mean? You have carboxylic acid, and you have another carboxylic acid functional group. That's why dicarboxylic acid. And in between, you have, in this case, you don't have 6 carbons. Here you have another group called, here you have another compound, which is benzene. Who cares? You learn benzene in A2, but we are going to just represent it with a box, right? And it's like a ring-like structure, like something like this. Nobody cares. And here you have a diol, OH, and OH right here. And again, we sandwich we sandwich everything what's present inside the box, right? So we're going to sandwich. It's basically two, you have like your, what's it called? You have CH2, CH2. That's what's present inside this box, but who cares? It's a diol for us. Okay, sir. So what's going to happen? Yeah, it's basically like esterification. What's going to happen? What's going to happen? This is one repeat unit, right? The carboxylic acid loses the OH and the alcohol loses the H. Carboxylic acid loses the OH and the alcohol. Just like in esterification, carboxylic acid loses the OH, the alcohol loses the H. So they go out to show the connectivity. But this OH and H, we make them go away to show the connectivity bond. So you just join them right here. And these are my connectivity bonds, right? We tell the examiner that this can go on forever and ever and ever. Not forever, but you know that you can have a lot of molecules like this, right? Now, this is just like, it's very easy. I know. This is just like, somebody said this, just like esterification. In esterification, what would happen? A carboxylic acid would react with an alcohol to give an ester. Why? The carboxylic acid loses the OH, the alcohol loses an H, and is called an ester. Similarly, in esters, the bond that was forming was C double bonded to O and bond single bonded to, and I told you it's ester because of this linkage right here. That's why terylene are also known as polyesters. They're synthetic polyester because of this ester linkage right here. It can have many ester links. I've just drawn one repeat unit. Acha, how do we know the repeat units? How many repeat units are in this structure? Can anybody tell me how many repeat units are in this structure? Repeat unit means a particular, you look at the entire chain and you are going to, and you can only do this from practice. You look at the entire chain and you're going to see after what particular point is the structure repeating itself. Check this out. This is CO, it's going, okay, CONH, it's not repeating. After I'm done with this, after this, look at this. This exact structure has been repeated here. So there are 2 repeat units, not 3, please. Okay, so you have to check out. देखिए ये पूरा एक structure है और ये पूरा का पूरा replicate हो गया. So after, you have to check where the structure starts to replicate itself, and the number of replicas that you have is equal to the number of repeat units. Like in addition polymers, look at this. How many repeat units are there? It's 1, 2, 3 because it's repeating itself 3 times. No, the examiner will never say draw the atoms in the box. It will never say that. It will, although what it does is nowadays to confuse you, it's going to show you what's present inside the box by itself. So you have to ignore it, just like I showed you right here. You have to ignore it. Like in nylon 66, what will he do? What he'll do is he's going to basically he's going to basically like show you okay, OH, CH2 4 CO. You're going to look at this and go, what the crap is this? Just notice carboxylic acid, carboxylic, dicarboxylic acid. This Dumbo is trying to confuse me by elaborating on the box. So you're going to notice this a lot in the MCQs as well. So they are polyesters, and terylene are synthetic polyesters. Why are we calling them synthetic polyesters? Because they are man-made. And what are some uses of terylene, everybody? Some uses of terylene. They're used in clothing, again, widely used in clothing. They're used in bed linen. प्लास्टिक में इस्तेमाल होता है टू सम एक्सटेंट. इट इज वाटर बॉटल्स वगैरह में. यस यू आर राइट, वाटर बॉटल्स में इस्तेमाल होता है ज्यादातर. वाटर बॉटल्स में, बेड लिनन में इस्तेमाल होता है. अच्छा, वन मोर थिंग गाइस, we know how to find out the monomer from looking at the polymer, right? Because we put a cut after every at the ester linkage, and between 2 cuts you're going to have your monomers. Why can we put the cut? They are actually biodegradable, everybody. They are, all these condensation polymers are biodegradable. What do you mean by biodegradable? You can basically convert them back into its monomer. They can all be converted back into its monomer. There are substances which can be broken down or decomposed by the action of bacteria. They can be broken down back into its monomers. Addition polymers को हम मोनोमर्स आइडेंटिफाई कर सकते थे, लेकिन वो टूटते नहीं है मोनोमर्स में, दे आर नॉन बायोडिग्रेडेबल, दे डू नॉट हैव एनी एक्टिव साइट, व्हाट नॉट एंड ऑल ऑफ दैट स्टफ. These can easily be broken. They're chemically unreactive, those polythenes and all of that good stuff, right? But they are chemically reactive. They can easily be broken down. How are they easily broken down into its monomers? This has now been removed from your course. It's called hydrolysis. You basically, the water that was removed, you add it back. You know, how was this polymer formed? This polymer was formed by removing a water molecule. By removing a water molecule, see, one water molecule is removed. Acha, how many water molecules have been removed? One water molecule here and one here. This is basically showing we removed the water molecules from here, the OH and the H, just to show the connectivity bonds. This hasn't actually taken place. The actual water molecules that have been removed are 1, 2. These two were removed to show the connectivity bonds. What cannot be broken down? Addition polymers cannot be broken down. We just literally learned the entire problem with plastics, right? So it's called hydrolysis. What happens in hydrolysis? You basically add back the water. Hydrolysis is the addition of water. It's the chemical. Hydro means water. Lysis means breakdown. So it's the chemical breakdown of substances by adding water. It's the breakdown of substances by adding water. And what would we do? We would not add water as in H2O. We would add water in the form of acid. So we would add dilute hydrochloric acid, and we would heat it. This is no longer in your course. I'm teaching you this because when you're doing previous past papers, you're going to come across hydrolysis. Literally, I said it like 20 times, man. It's no longer a part of your course. But because you'll be doing previous year's past papers, it's such a small concept. What is used to go to convert back the polymer into the condensation polymer into its monomer? You perform hydrolysis, which is the breakdown of substances by adding water. And how do you do that? You use dilute acid and you heat it. That's it. Now, the last polymer that is in our course is protein. Protein is what is protein actually? Sir, but we did break down wala addition polymer. Yes, I said tuba. Nowadays, I said that plastics, you have degradable plastic. That was just an extra information. Okay, nowadays, you have degradable plastics. When we talk about addition polymers, we talk about it in terms of वो plastics जो कि degrade नहीं होते. They are non-biodegradable first. Nowadays, science has advanced so much, man. You can literally make plastic you can literally make such plastics which can dissolve in water, which can break down, degrade if you add water to it. You can literally make plastics from, it's called bioplastics, biopolymers या bioplastics. I don't know the exact word for it. Biotechnology में इतनी advancements आई हैं. Literally, you can make plastics out of trees, out of the trunks of plants. अच्छा, प्रोटीन क्या बला है? प्रोटीन बनता कैसे वैसे? All the protein, in our body, all of that good stuff. This is now natural polymers. We're done with synthetic polymers, right? These natural polymers exist in nature as they are. Now, protein कैसे बनते हैं हमारे जिस्म में? Basically, extra information दे रहा हूँ. Your DNA, what's DNA? Deoxyribonucleic acid. So the DNA that every human has, सुबह उठ के देख लेना जी जी. The DNA is that every human has, it encodes certain information, and because of that encoding results in the synthesis of protein. So it encodes information that is necessary to synthesize protein. And proteins are literally all around us, man. They are literally all around us. The catalysts in the catalyst, the enzymes that act as catalyst for reactions in our body cells, these enzymes are proteins. Hemoglobin, heme stands for iron, globin is basically a protein that transports oxygen to every cell of your body. The keratin, आजकल तो वो फूशल भी आया हुआ, keratin, जो keratin से आपके बाल बनते हैं. Keratin, literally, your hair, it is made from keratin. That is protein. Your collagen is protein. The collagen in your skin, bones, hair. Sorry, hormones are all literally proteins. They're all proteins. That all the hormones that help us, grow, develop, all of that stuff. They're all proteins. And what are proteins made up of? If you've studied biology, you know that proteins are made up of amino acids. Many amino acids are going to join together to give you this large polymer called protein, right? Many amino acids. How many amino acids are there? I think there are 20 or 22 amino acids. Yeah. I think there are 20 or 22 amino acids. I don't recall. Can somebody check it and then let me know? as well. 20? Okay, there are 20 amino acids. I think 20 or 22 the jo bhi the. And 9 to 10 amino acids are very essential for us. So we need to have the best intake of protein. And protein is found in, like, your meat, your eggs, vagera, in the egg yolk and all of that stuff, right? Now, the monomers for protein is like your amino acids. Amino acid, what is the structure of amino acid? Amino means the NH2 group. Acid means the COOH. That is the reason why the name amino acid is there, because the amino literally means the NH2 group. The acid literally means the COOH group and the COO group, right? And in between, there is a box. And this box contains, basically, I'll tell you, this box contains a carbon, which is bonded to hydrogen, which is bonded to R. You need to know this. And this R, what is this R? This R basically represents different types of side chains, different types of side chains. So you just basically, this R can be like CH3, it can be H, it can be C3H7, and so on and so forth. So you have like all the different 20 different, because you have 20 different types of amino acid. Every time the R will vary, the protein will become different, right? So if the R is like H, you call it glycine. If the R is CH3, you call it alanine. If the R is like C3H7, you call it cysteine. You have valine, you have serine, you have so many enes, yeah? You will study all of them in A levels. No longer needed, right? But you just need to know that the R represents the different types of side chains, and we sandwich it. Iska link kaun sa hoga? Chill out. We sandwich it. So it's NH2 box and COOH, right? How do you make protein? Let's take amino acids. So this is my amino acid A, and let's take an amino acid B. Draw it, please. Yeah? Amino acid A, amino acid B, please. अच्छा, आपका सिलेबस ना ज्यादातर इसको ऐसे नीचे की तरफ शो करता है, तो कर ले नीचे की तरफ, लेकिन जरूरत नहीं है, वो एक ही बात है. ओके, व्हाट्स गोना हैपन? Amino acid A, amino acid B. What's going to happen? What's going to happen? The carboxylic acid, because you have the amine group and the acid group on the same box, right? You can literally take this amino acid and form a polymer out of one amino acid. How? You take this amino acid and you join it again with this amino acid. Just make sure that the amine faces the acid and the acid faces the amine. So the acid is going to face the amine, and obviously the carboxylic acid is going to lose the OH, the alcohol is going to lose the H. It's going to give you H2O, and to show the connectivity bonds, we remove the H right here and we remove the OH here. The carboxylic acid loses the OH and the amine loses the H. Although in total only one water molecule has been removed, this is just to show the connectivity bonds, and you just bond them. Boom. That's boom, 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 and that's your protein. And you show these are my connectivity bonds. And protein also has the CONH bond right here, and if CONH bond is which bond? It's the amide linkage. It has the CONH linkage, which is the amide linkage. That's why proteins are also called as polyamides, and in bio you mostly call them polypeptides. Yeah. And what is the, if the examiner says draw a circle around the amide linkage, that's the circle around the amide linkage. Sorry for my circle, but that's the amide linkage, right? That's why proteins are polymer. But what's the difference between proteins and nylons? The difference is that proteins are natural polyamides, and your nylon is synthetic. This is protein and that's nylon. Nylon 66 and protein, right? So protein is a natural polyamide, nylon is synthetic polyamide. And what's the other difference? The difference in monomers. Protein has monomers which are amino acids, and nylon, they can ask you about the difference. Nylon has a monomers which are dicarboxylic acid and diol. And you could literally just by looking at the structure find out whether it's protein or whether it's nylon. In nylon, you're going to notice that at left and right hand side of the box, you'll have the same group. At the left and right hand side, you'll both have COO, COO, N, N, just to make things easier for you guys, right? So N, N, COO, CO, N, N, COO, CO, right? But in proteins, you're going to notice at the left of the box, you're going to have the N, and the right of the box, you're going to have the COO, or the left, you're going to have COO. So there are going to be two different atoms at the left and right hand side of the box. That's how you can easily determine it. Both have the amide linkage. Yes, one is polyamide, the other one is also polyamide, but one is natural, one is synthetic. What is the similarity between nylon and protein? Both are polymers. Just give me 5 more minutes. I will finish this class, right? Bas khatam ho gaya. And Fats has now been removed from your course, but fats are also polyesters. That's what you need to know. Fats are also polyesters, and polyesters, they are polyesters, but they are natural polyesters. So if the examiner says, what is an example of natural polyester? That's fats. And what is the example of a synthetic polyesters? That is terylene. So terylene is a synthetic polyester, and fats is a natural polyester. Fats is made up of one glycerol and three fatty acids, right? So it's made up of three fatty. What are the monomers for fats? Glycerol and fatty acids. One glycerol bonds with three fatty acids. What's the structure? It's no longer in your course now, right? And terylene has different monomers, which is dicarboxylic acid and diols, right? And what is the similarity between the two? Similarity is both are polyesters. Sir, you know biology? I hate biology. नायलॉन में डायमीन नहीं है, आपने डायोल लिखा है. Oh, thank you. Dicarboxylic acid and diamine. My bad. Thank you. Yeah, brain not braining. So that's all there was. Starch भी एक जमाने में था. Starch has now also been removed. Starch क्या है? Starch का monomer है glucose. How do you represent glucose? अच्छा, if they ask you to make the structure of fats, you literally just make the structure of terylene. That's it. Fats का structure मांगा है, you take dicarboxylic acid, diol, and make it the same way as you make terylene, right? Although the structure used to be in the course and it used to be different, but now for 2023, thank the Lord, it has been removed. And because we are just learning syllabus focused, we're only focusing on the syllabus. We're not going to discuss the structures, although I always discuss them, but no use. And your starch is also another polymer. It's also known as polysaccharides, right? So starch as my polysaccharides, and they are made from glucose, many glucose combined together to give you starch, right? What's the structure of glucose? Glucose has a very complex structure, but you represent it something like this, right? So you take glucose, you take another glucose, and you say, okay, the first glucose loses the OH, this loses the OH, this loses the H, this will lose the H, this will lose the OH, and you just bond them together. And this bond right here is called the glucosidic linkage. I'm going very fast over this because it's not in your course. This is the glucosidic linkage, and these are my connectivity bonds, but it has now been removed from the syllabus. One last thing that is left is the difference between condensation polymers and addition polymers. What's the difference between condensation polymers and addition polymers? This is very important. This has been in your syllabus from a long time, and this was last time that this was tested was way back, right? So the differences have never been tested in so many years. So what's the difference between condensation polymers and addition polymers? The first difference is that addition polymers are made through an addition reaction. Condensation polymers are made through a condensation reaction, right? So condensation reaction hota hai. In addition polymer, it only makes one product forms. In condensation polymers, you also have a byproduct, right? It produces a byproduct, which is the small molecule. In this case, it's water, right? Similarly, there's one last difference. I'll write it down, which is not in your course, which is basically like condensation polymers, they form heterochain polymers. Condensation reactions form heterochain polymers, and they form homochain polymers. What do you mean by heterochain, homochain? Not in your course. I'm just giving you an extra difference between them. So if God forbid they say, okay, oh, these two, write two more differences, and they they mention this in the question, then you could write these two. Heterochain basically means, or homochain basically means that the chain, the main chain is constructed from atoms of a single element. So if you check this out, in addition polymers, if you check this out, the main chain is always made of atoms of a single element. They're all carbon. It's like A bonded to A, bonded to A, bonded to A. All the ups and downs are something else, but the main chain remains the same. And the main chain is made up of atoms of a single element, right? And heterochain basically means that the main chain will have different, like it has the N, it has the H, it has the C, N, C, N, C, N, C. So they have different atoms in the main chain. That's heterochain polymers. Condensation polymers, we've noticed right here, it has different atoms in the main chain. Let's do two examples right here. I'll just finish off this stuff. Can somebody tell me? Can somebody tell me? Is this like your? Is this your? Is this my? Is this my nylon or is this my protein? Those of you who find it difficult, please do not give direct answers, right? Do not give direct answers, please. Always, if you find it difficult, don't come under the pressure of your peers. What have I taught you? Put a cut at the linkage, put a cut at the linkage, put a cut and put a cut at this connectivity. Between two cuts, you're going to have your monomer. Between two cuts, obviously shade one box. Yeah? Between two cuts, you're going to have the monomer. So check out the monomer. Check this out. What is this? This is the N bonded to H, which is bonded to the box, bonded to C double bonded to O, and this C double bonded to O lost the OH, give it back its OH, this lost the H. This is amine, this is acid, this is amino acid, and therefore it's protein. So if you get scared, just draw a cut at the linkage. You do not need to be Einstein का बच्चा कि यार नहीं मैंने भी मेरे दोस्त डायरेक्ट कर रहे हैं तो मैं भी डायरेक्ट करूँ. हाँ, one more thing, one more difference. मेरे जहन में एक और difference पे आया. In condensation polymers, you must have at least two different or similar functional group. You must have at least two different or similar functional groups, right? This is COOH and like your NH2. So they must be two different or similar functional groups. In addition polymers, the monomers, right? In the addition polymers, the monomers must have at least a double bond. Must have at least a double bond. And that's it, right? So you can easily go back into. And if I ask you guys how many water molecules were formed, so one water molecules were formed by making this linkage, one was formed by making this linkage. These are just the connectivity bonds that we show. In total, 2 water molecules have formed, not 3. The third one that we removed here was just to show the connectivity bond that this can go on and on and on and on, right? So, and if I say draw a circle at the amide linkage, this is my amide linkage. Boom shakalaka. So these are all the questions related to esters and polyesters and polyamides and all of that good stuff. We are officially done with your organic chemistry. The only thing that is left is fractional distillation. I can't be just my energy is finished. Do you want me to just quickly sum fractional distillation up? Organic chemistry is finished. I hope fractional distillation is easy, yaar. Crude oil. Why would we draw the terylene structure if we ask for fats? Because fat structures is no longer in your course. Alag cheese hai, but it's no longer in course. For fats, you use glycerol, and the monomer is glycerol and fatty acids. So glycerol is an alcohol. Fatty acid is an acid. So alcohol and acid. So you can literally say diol and dicarboxylic acid and made fats. But he is not going to ask you to make fats because he's removed it. Fats ka structure pehle kuch aur hota tha. But if he God forbid asked it, you just draw the structure of terylene because for your knowledge, it's the same. Then I'm going to stop the recording right here. Sir, if we instead of the C2H5 in the addition polymerization, can we write CH2 and CH3? Absolutely you can. Absolutely you can. It's your choice. Absolutely you can, right? And that's basically it. I'm going to I can't be bothered to do fractional distillation because it's very easy. Do you want me to just go over the process of fractional distillation very quickly? Just the process. You need to know the uses of every fraction, but just the process because you guys mess up the description. Do you want me to describe it quickly? Do you want me to describe it quickly? Quickly? Okay. Quickly describing fossil fuels. What are fossil? I'll just use English here. जिन्होंने बाद में लिखना हो लिख लेना. मैं सिर्फ अंग्रेजी बोल रहा हूँ. अंग्रेजी सुने. Fossil fuels. What are fossil fuels? Fossil fuels जो हैं, they're basically derived from fossils. What do we mean by fossils? Fossil fuels are fuels formed from like these dead plants. These fossils are basically dead plants and dead animals which fossilize over 200 million years or 300 million years, and they make fuels, right? And why do we call them fuels? We call them fuels because they release energy when they undergo combustion, right? And you need to understand that fossil fuels are non-renewable resources, which means that they are going to deplete over time. What are the examples of fossil fuels, everybody? You should be able to name 3 examples of fossil fuels. What are the 3 examples of fossil fuels? Coal, petroleum, natural gas. These are the 3 examples of fossil fuels. How is coal formed? You don't need to know how coal is formed. It's basically, in these swamps and so on and so forth, these vegetative matter would decompose, the vegetative matter would decompose to form coal over millions of years. Petroleum, how is petroleum formed? Petroleum is also known as crude oil. Petroleum is basically formed from the remains of dead organisms. जो ocean में गिरे हुए dead organism hai, which have been buried under thick sediment. जो high pressure है, slowly and gradually the high pressure under these ocean beds convert it into petroleum over millions and millions of years. Natural gas is the main constituent of the main constituent of natural gas is methane, and natural gas is often found wherever petroleum is found. Natural gas भी उधर found हो जाता है. But you can also obtain it from the fractional distillation of petroleum. What is petroleum? Petroleum is a mixture of hydrocarbons, everybody. You need to understand that petroleum mostly consists of alkenes. Alkenes होते हैं, but in a very small amount, in a very small quantity. That's why we say that petroleum only is a mixture of hydrocarbons and mostly it's alkenes. तो alkenes किधर से आती है? From the cracking of alkenes. हाँ, petroleum के अंदर भी present होते हैं alkenes, but they are in such a lower amount that we don't even consider them. So we say कि basically petroleum is a mixture of hydrocarbons, and the hydrocarbons that is present in the maximum amount is your alkenes. And you literally obtain all these alkanes directly from petroleum by performing fractional distillation. And once you perform fractional distillation of petroleum, you get alkanes. And that's why we said that alkanes are the starting point of all the other families. So alkanes are the starting point. How do you obtain alkanes? We learned everything, how we obtain all of these organic families, organic molecules, but we did not learn how we got alkanes. Alkanes are gotten or obtained from the fractional distillation of petroleum. How do you perform the fractional distillation of petroleum? The fractional distillation of petroleum, learn the description. It might be tested in your theory paper. What happens is petroleum, these are the points that I'm giving you, 3 points for fractional distillation. The petroleum is heated to about 400 degrees Celsius because we want to vaporize it before it enters the fractionating column. So petroleum is heated to about 400 degrees Celsius so that it vaporizes before it enters the fractionating column. Wait. Right here, we vaporize it. We vaporize the petroleum right here. We vaporize it. The petroleum is heated to about 400 degrees Celsius to vaporize it before it enters the fractionating column. This is my fractionating column. Why am I calling it a fractionating column? Because point number 2, fractional distillation will take place and different hydrocarbons will exit through different fractions. These are my fractions. Different hydrocarbons will exit through different fractions based on boiling points, right? Because every single molecule has a different boiling point. So this is point number 2. And point number 3 is that the fractionating column has a heat gradient. What do we mean by a heat gradient? This is just further explanation. Heat gradient means that it's very hot at the bottom and very cool at the top. So because it's very hot at the bottom, the longer chain hydrocarbons will be collected at the bottom. The shorter chain hydrocarbons will be collected at the top. Okay, but if I ask you certain questions, okay, what will happen to the chain length as you go from bottom to the top of this fractionating column? So obviously at the top, the chain length is going to be lower, right? It's going to have a decreasing chain length. Here you have a longer chain length of hydrocarbons. That's why it's very thick liquid, solid liquid, and all of that good stuff. So what happens to the volatility as you go up the fractionating column? The volatility increases because up the fractionating column, you basically get your refinery gas here, which is known as natural gas or cooking gas. You use it for heating and cooking, all of that good stuff. Here you basically get your gasoline. Here you get your naphtha. Naphtha fraction is used for chemical feedstock. Gasoline is basically petrol. Gasoline fraction or petrol fraction, you use it in as fuel for cars. The fourth fraction, if I'm not wrong, is kerosene. Kerosene is matti ka tel. Paraffin is also known as paraffin. It is used for jet fuel. This fraction is diesel oil or gas oil fraction. It's called diesel oil fraction, or you can also call it a gas oil fraction. And diesel, it's used for diesel engines. It's used for fuel in diesel engines. This is basically fuel oil fraction, right? It's fuel oil fraction, जो कि basically it's used for ships. It's used for fuels in ships and home heating systems में इस्तेमाल होता है. This is the lubricating fraction. Now this is very thick liquid. It has carbon chains or up to like 30 to 40 carbon chains, and it is used because it's lubricating. The name itself tells you that it's used in lubricants, and you also use to make waxes and polishes. This is bitumen fraction. This bitumen fraction is used to make roads, and that is it. If I ask you what happens to the viscosity as you go from the bottom to the top, so obviously if the chain length is decreasing, so from bottom to the top, the viscosity should also decrease. Solids are more viscous than gases. You just have to keep in mind that if this is the solid, this is the gas, you know all the other physical trends. You all know all the trends in physical property. What would happen to the size of the molecules as you go from bottom to the top? The size will decrease. What happened to the boiling point? The boiling point decreases. What happens to flammability? Flammability increases. All of that good stuff. That is it. I also discussed the entire fractionation, the fractional distillation of petroleum, and this is the end to your organic chemistry. Please note that we have not not left even a single detail in organic chemistry. Just a summary diagram is left, which I cannot be bothered to make. So we are done with the entire chemistry in 7 hours, organic chemistry. And we did not just do the crash course for it. Mind you, we did not do the crash course. This is the complete conceptual understanding of organic chemistry. We do not skip on any concept. We did not skip on anything whatsoever. So if you take these 2 videos and then you start solving past paper questions, things are going to be so easy for you. They're going to just be buttery smooth. The only thing you guys need to do now is to practice, and inshallah, hopefully tomorrow I practice with you guys as well, or tomorrow we just do moles, right? So wish me the best of luck. Thank you very much. It was a pleasure. You guys can ask me any questions. Let me just stop the recording and you guys can ask any question now.